the name indicates, supervised learning has the presence of a supervisor as a teacher. Supervised learning is when we teach or train the machine using data that is well labeled. You have already gone through the fundamentals of supervised learning. In this tutorial, you will be learning and practicing several different projects under this beautiful machine learning algorithm. Starting from COVID-19 outbreak prediction, Pokemon trainers using R, credit card fraud detection, and credit card defaulter prediction. So get ready to witness the practical implementation of supervised learning algorithm in ways you have never seen before. If you haven't subscribed to our channel yet, I want to request you to hit the subscribe button and turn on the notification bell so that you don't miss out on any new update or video releases from Great Learning. If you enjoy this video, show us some love and like this video. Knowledge increases by sharing, so make sure you share this video with your friends and colleagues. Make sure to comment on the video for any query or suggestions and I will respond to your comments. Now let me very quickly walk you through the agenda for this course. In today's course, we are going to look at COVID-19 outbreak prediction, Pokemon trainer using R, credit card fraud detection, credit card defaulter prediction.
The year of 2020 was hit by the coronavirus pandemic, leading to disruption of lives all across the world. Many data scientists and machine learning experts have been working along with medical experts to understand the spread of this virus and how to stifle its growth. People with expertise in ML have been working on machine learning models that detect COVID-19 and also predict the severity of COVID-19. On the same lines, we'll be taking up a project titled Predicting COVID-19 using Machine Learning, where we'll understand the spread of COVID-19 across the world using some data science techniques. So let's get started.
So let's start by understanding the concept of machine learning with this example over here, right? So what exactly do you see in this slide? What is this, right? Can you tell me what is this? It's simply a pen, isn't it? Now, what about this? This again is a pen. And this? Well, this too is a pen. So now I have a question to you folks. How do you know all of these are pens? It's a simple question, isn't it? So you just look at a pen and you know that it is a pen. But how does your brain identify that it actually is a pen? So what is happening in your brain? So what happens is, so let's say as a kid, you would have been told by your kindergarten teacher or your parents that this is a pen. And your brain learned that this is how a pen looks like, right? So you learned all of the features of this pen. You understood that a pen has a nib over here. You understood that this is how the pen's body looks like. So now that you've learned all of the features of the pen, whenever you come across a new pen, whenever you come across a pen or a picture of a pen, you can easily identify it that it is a pen. And this is how your brain functions. Now, what about a machine? So as I've told you, so how do you know all of these are pen? Because your brain already learned all of these features associated with the pen, and whenever your brain encounters a new pen, it knows that it is a pen. Right. Now, as I'm asking you, instead of giving this image of a pen to a person, let's say if I feed in this image of a person to a machine, how will a machine be able to identify that this actually is a pen, right? So how does a brain have that processing power to understand this is a pen? So does the computer over here or the machine over here have a brain to understand that? So this is where machine learning comes in. So what we'll do is we'll keep on feeding these images of a pen to this machine until it learns all the features associated with the pen, right? So as you see, this is how our brain functions as well. Our brain looks at a lot of images of pens, or when we look at these pens or images of pens, and we've been enforced, right? We've been told again and again by our parents or by someone else that this is a pen, and our brain learned. So we'll do the same thing over here to the machine as well. We'll take the first image of the pen, we'll feed it to the computer, and we'll tell the computer that this is a pen. Similarly, we'll take the next image of a pen, we'll feed it to the computer, and we'll tell the computer that this again is a pen. And then we'll take another image of a pen, we'll feed it to the computer, and we'll tell the computer that this again is a pen, right? So now, this is how the computer learns all of the features associated with this. Now, once it learns all of the features associated with this, I will give it a new pen, right? This is known as the test data. Now, on the basis of this, I would want to understand how much the machine has actually learned. So this is the underlying concept of machine learning. So we keep on feeding images of these pens to the machine until it learns all of the features of the training data. And once the training is done, we will give it the test data to understand how much it has learned. So as you see over here, this machine has learned the features of all of the images perfectly and it predicts it perfectly, right? So when we feed in this new image of a pen, it is perfectly able to classify that this is a pen. So these are some underlying concepts of machine learning. So now that we know what exactly is machine learning, let's go ahead and look at some subcategories of machine learning. So machine learning can be broadly categorized into supervised learning and unsupervised learning. So let's start with supervised learning. So in supervised learning, we have input variables and output variables. The input variables are denoted with X and the output variables are denoted with Y. And we basically try to understand what is the relationship between Y and X. Or in other words, we're trying to understand if X changes, how much does Y change along with X. So here the input variable is known as the independent variable and the output variable is known as the dependent variable because output is dependent on the input, right? So these are some basic concepts of supervised learning. And in supervised learning, you have data which is labeled. So this is very important to understand when it comes to supervised learning. You have data which is labeled. So now that we know what is supervised learning, let's understand the categories in supervised learning as well. So in supervised learning, we have regression and classification. So when it comes to regression, let's actually start with classification over here, right? So in supervised, as I've told you, we have regression and classification. So let's start with classification. So classification, as it is stated over here, is the process of predicting the class of a new variable. So let's say if there's a problem statement like this, I do want to understand if a patient has cancer or not on the basis of whether he smokes, right? So here, smoking would be the independent variable and having cancer or not would be the dependent variable. So I'm trying to understand if the person smokes or not. On the basis of that, I'd have to predict whether the person has cancer or not. So over here, I am trying to predict a class to the patient. So the class is either having cancer or not having cancer. Yes or no. So this is what is known as classification. So that was the brief on classification. Now let's understand regression. So regression is again very simple. It's just used to estimate the relationship between two different entities. So again over here, Y would be our dependent variable, X would be our independent variable, and we try to estimate a relationship between these two. Now I'm just briefing you guys through all of these algorithms because today's main focus is on the COVID-19 data analysis. So all of those guys who are new to ML or new to Python, I'm just making sure that you guys know the brief of what is machine learning, what is supervised learning, what is unsupervised learning, right? If you want to learn more comprehensive stuff, then you can check out all of the comprehensive algorithms on our YouTube channel or on Great Learning Academy, right? So you have access to all of that over here. But today's main focus is COVID-19 data analysis, and I'm just giving you a brief on all of this basic stuff. Right, so now that we know what exactly is supervised learning, let's go ahead and understand unsupervised learning. So when it came to supervised learning, there was data with labels. But when it comes to unsupervised learning, we have input data with no class labels. So as we see over here, we have images of cars and bicycles. But there is no label associated with this, right? So you just collected random images of cars and random images of bicycles. So you as a person or you as a human being know that these are different, right? Bicycles are different than cars. But again, if I feed all of these images to a computer, how will it be able to identify that these are different? So this is where an unsupervised learning algorithm comes in. So this unsupervised learning algorithm, it is used to understand the underlying structure of the data. So here we have an unsupervised learning algorithm called as clustering. So we have applied this clustering algorithm on top of this data, and with the help of that, we are able to divide this data into two groups, right? So as you see, this first group comprises of all the cars, and the second group comprises of all the bicycles. And this we are able to do with the help of this unsupervised learning algorithm. So there are two concepts over here. One is known as intra-cluster similarity and other is known as inter-cluster dissimilarity. So as you see over here, when I talk about intra-cluster similarity, that is the items or objects which are present inside a group, they are very similar to each other. And the items which are present in two different clusters, they are very dissimilar. So we have all of the cars in this cluster, so there is very high intra-cluster similarity. And when we compare these bicycles to these cars, or both of these items are very different, and that is why we call it as there is very high inter-cluster dissimilarity. So we were able to, we had all of this data with us, and with the help of this clustering algorithm, we were able to divide this into two different parts, and we were able to do this on the basis of the similarity of the characteristics of the data, and this the clustering algorithm understood on its own. So we'll understand the concept of linear regression with this case study over here. So let's say you're sort of conducting a supervision on all of the students in your college, right? And let's just assume that all of the students in your college have given the GRE exam. Now, you would want to understand if there's a relationship between the CGPA of the student and the GRE score of the student. Right? So I'll repeat the case study again. So here you have two things. Here basically all of the students have given the GRE exam, and obviously all of the students will have a CGPA associated with them. So we are trying to understand if there is a relationship between the CGPA of the student and the GRE score of the student. That is, the question is over here is something like this. If the student has high CGPA, will the student also get a high GRE score? Right? So to answer that, we would need the help of linear regression. So our first task would be to gather all of the data. So what we'll do is we'll go to all of the students, we'll ask them their GRE score, and we'll also ask them their CGPA. And then we'll go ahead and make a table out of this. So as you see, we've made a table where in one column we have all of the GRE scores of the students, and in another column we have all of the CGPA of the students. So now that we have this, what we can do is we'll start off by making a simple scatter plot. And over here, since we want to understand how would the GRE score vary with respect to the CGPA, here we will map the CGPA onto the x-axis and we will map the GRE score onto the y-axis. And as this plot suggests us, as the CGPA of the student increases, the GRE score of the student would also increase. This basically means that if the student has a high CGPA, then the student will also have a high GRE score. Right? So this is a very simple analysis which we can get from this plot over here. So that is why data visualization is also very important when it comes to machine learning. All we've done is made this plot, and with the help of this plot, we were able to identify that if a student has a high CGPA, then the student will also have a high GRE score. So now that we know this, let's go ahead and change the question. Now we know the exact value of CGPA. Let's say the exact value of CGPA of a student is 8.32. Now, depending on this CGPA, I'd want to predict what would be the GRE score of the student, right? So let's say 8.32 would come somewhere over here. So if 8.32 is somewhere over here, your GRE score could be scattered all over these points, right? So it could range from 300 to let's say 320. Now, how would you exactly predict when you know that the CGPA is 8.32? How would you predict what is the GRE score? So this is where we'll go ahead and use the concept of linear regression. So what we'll do is we'll go ahead and make a line over here, right? So we'll make a line. Now let's say if 8.32 comes over here. So what we'll do is we will make a line from here to here. So if 8.32 is here, we'll draw a line from here to here. And whatever point comes on the line over here, that would correspond to the y value. So if it comes over here, this would mean that let's say the GRE score would be 310. So what we've basically done is we have drawn a line which passes through all of these points. And as you see, y is equal to a plus bx over here. But how do you know that this is the perfect line over here? You could have another line like this. Similarly, you could have another line like this. You could have infinitely possible lines over here. So out of all of these lines, how would you know which would be the perfect line, right? So any guesses, any answers over here, right? So guys, you can go ahead and keep posting your answers in the chat, right? I'll also take them up, right? So the basic answer over here is, we'll understand that through this example. So here again we have all of these dots over here. We have x and y. Now what we'll do is, we will go ahead and make a line like this. Now as you see, this line basically gives you the predicted values, and these dots are the actual values. So this difference which you see between the actual values and the predicted values, that is known as the residual, right? So all of these, so whatever lies on this line, those are the predicted values, and whatever are there on the subsidiary, there are the actual values. So this is known as YP, and this is known as YO. So Y objective, or Y actual, and Y predicted. And the difference between the actual and predicted is known as the residual. Now, the best fit line would be that line which would have the sum of residual squares to be the minimum. I'm repeating it again. So you've seen that there could be infinitely many lines possible. So out of all of those lines, the best fit line would be that particular line which would give you the minimum value of y0 minus yp whole square. So this basically means the minimum value of residual sum of squares. So here what we do is, we subtract this minus this, we get the residual. Similarly, we do this minus this, we get the residual. We do this minus this, we get the residual. And then once we do that, we take the square of the residual, and then we add the square of residual of this, and then we add the square of residual with this. And then we get something known as residual sum of squares. So as you see, let's say if we draw 3 lines like this over here, the residual sum of squares for this line is 28. The residual sum of squares for this line is 22, and the residual sum of squares for this line is 24. Now, when we compare these 3 lines, the residual sum of squares for this yellow line is the minimum, and that is why this would be our best fit line. So this is how we can go ahead and find our best fit line. So now that we know the best fit line, what we have to do is, since we already know the value of CGPA, which is 8.32, we'll just mark that upwards over here, and we'll get the corresponding value of y as well. We'll do some data analysis on this COVID-19 data set. So this data set we've got from the website Our World in Data. So we'll put the description, we'll put the link in the description. You can check it out once the live is done. Right. So first, this might be a bit comprehensive to all of the folks who are new to Python and new to ML. So I'll try my best to explain this to you, clear all of your doubts. If you have any doubts, please keep posting them, right? Any doubts, please keep posting them. So our first task would be to import the pandas library. To those of you who don't know what exactly is pandas, this library is mostly used for data manipulation, and with the help of this, we can load whatever CSV files we have. So we'll be using the read_CSV function to load up the covid.csv file. So this is the name of my file. So if you guys need this file, the link of this would be available in the description once the session is done. Right, so I'm loading this file, and I'm storing this in an object called as COVID. And I will go ahead and I'll have a glance at the head of this data set. So this head function gives me the first 5 rows of this entire data frame. So as you see, we have all of these columns over here. So we've got this ISO code, which is basically the ISO code for the country. Then we have the location. Location is basically the different countries over here. So we have around 207 countries, I guess, in this data set. And then we have the date. So as you see, the date, it varies a lot. I guess the date, the analysis starts from around 31st or 31st December 2019, and it goes up to 23rd of May 2020. And we've got all of these different details over here. So we've got the total cases column, which would tell us the total number of cases till here, right? So in Aruba, on 13th March 2020, there were total 2 cases. Similarly, in Aruba on 26th March 2020, there were in total 19 cases. These are the new cases which occurred on that particular day over here. So in around 26th March 2020, there were 2 cases found, right? So this is about the total cases and the new cases. Similarly, you have the total deaths which have occurred on this particular date over here. So as you see, till 26th March, there have been no deaths in Aruba. Similarly, we've got a lot of different columns over here. Now we'll go ahead and look at the shape of this data set. So we'll just type in COVID.shape. So this shape method gives us the number of columns and the number of records in this data set. So this tells us that there are 19,496 records and 32 columns. Right, so these 19,496 records are with respect to all of the countries over here. Now we will go ahead and see what are the different locations present. So we'll just go ahead and type COVID, and so what we're doing is we are basically selecting this location column from this COVID data set, and we are checking the frequency of each of the location, that is how many records are present for each of these location. So we're just typing in COVID location dot value counts, and as you see, these are the different countries which we have. So we have 146 entries, or basically these are the 146 dates recorded for Canada. Similarly, 146 dates recorded for United States, 146 dates recorded for Japan, and so on. So we would have around 212 countries. So as you see, the length is 212 over here. So we have 212 different countries in this data set. And now we will understand the categorical columns in detail. So to understand the categorical columns, we'll be using the describe method. So we'll just type in COVID.describe include is equal to 0. So when we say include is equal to 0, this would give us a description of all the categorical columns. So here the categorical columns are ISO code, location, date, and test units. Now let's say if I go ahead and remove this include is equal to 0, let's see what happens over here. If I remove this, as you see, we have the description of all of the columns over here, right? So description of basically all of the numerical columns, but I don't want the description of all of the columns. I want the description of only the categorical columns. So that is when I'll just go ahead and set this as include is equal to 0. So let me just set this as 0 over here. Seems like we have an error over here. Include is equal to O. Let's see what is the error. Okay, so we'll just go ahead and remove this for now. So basically this would give us the description of categorical columns. Alright, we will go ahead and remove this. So now that we know that, let's go ahead and check if there are any null values present in the data set. To check if there are any null values, all we have to do is use covid.sna.ne. Now this SNA gives us a true or false values of all of the null values which are present in the data set, and this NE would just give a blank true or a blank false value with respect to all of the columns. Now you see we have a bunch of true and false values over here. So as you see, for the column ISO code there are null values present. Similarly for the column location there are no null values present. Similarly if we take this column over here, total cases per million, there are null values present. So almost for all of the columns there are null values present. It's only from location till new deaths where there are no null columns present. Right. So over here I am checking if there are any null values present. Now what I want to do is I want to get the total number of null values which are present in each column. So I'll just go ahead and I'll type in covid.is.na.sum. This is the name of my data frame. is.na would give me a bunch of true and false values, and the sum method will sum up all of those true values. So let me go ahead and click on run. So as you see, I have 64 null values in this column. I have 377 null values in this column over here. So it's only these columns. So I have these 5 or 6 columns where there are no null values. Similarly, if I take these male smokers column, I have around 5,206 null values over here. So that is how we were able to get the number of null values. Now what we'll do is, out of all of the countries which are present in this data set, we will go ahead and extract only those records where the location is India. right? So let me explain this command to all of you guys who are new to pandas. So first what we'll do is we'll type in the name of the data frame, which is COVID, and we'll give in parenthesis inside this, and we'll give in the name of the column, which is location, and we'll give the condition. So the condition is the location needs to be equal to India. Let me just keep the I to be capital over here. Now when I given this condition, this gives me a bunch of true or false values where the location is India. Now what after doing this, if I given COVID again, which is the name of the data frame, so what I'm doing is when I feed in all of these true or false values inside this data frame again, this is basically the same command over here, right? So this will give me all of the records where the location is India, and that result I am storing in a new object called as India case. Now let me go ahead and have a glance at the first 5 records of this India case. So as you see over here, the ISO code is IND for all of the records, and the location is India for all the records. So this is the starting date over here. So the starting date, as you see, this is 31st December 2019. So as you see, there are no cases on 31st December 2019. There are no reported cases at all. So India, so seems like there is no one who has come outside from India and who has spread the disease till now. And now what I'll do is I'll use the tail method. So some of you guys who already know Python would know that the tail method would give me the last 5 records of the data frame. So as you see, these are the last 5 records. So we have dates going from 20th May 2020 till 24th May 2020, right? So these are the last 5 days. And as you see, on 20th May 2020, the total number of cases were 1,67,050. This is actually 1,06,750. And as you see, these cases are exponentially increasing, right? Just in a span of 5 days over here, on 20th May, we had the number of cases to be 1,06,750, and on 24th of May, the number of cases increased to 1,31,868. Similarly, as you see, the number of new cases, we have almost 5,600 cases on 20th May, and on 24th May, we have 6,767 cases on 24th May. Right, so it actually seems like even during the lockdown, people have been moving a lot and people have been spreading the disease a lot. So it seems like we'd have to understand something from this, and we'd have to stay in our homes, right? And we'd have to make sure that we don't spread the disease to all of the elderly folks. So even though we might be young, there could be a chance that we are asymptomatic carriers. We would have the disease, but we wouldn't know that we would have the disease. So it's essential that we abide the lockdown rules properly, and we stay at our houses. So as you see, this is very problematic over here. We have more than 6,000 cases every single day. So this is not really good. And as you see, the number of deaths are also more than 100. So on 24th of May, we had 147 deaths because of COVID-19. Similarly, as you see, on 22nd May, we had 148 deaths because of COVID-19. Now that is very devastating, isn't it? On a single day, this disease called as COVID-19 is killing 148 people. That is truly saddening. Right, so these were some of the features which we saw with the help of this tail method. Now what we'll do is we will make a very beautiful plot by using the Seaborn and the Matplotlib libraries. So I'll go ahead and import the Seaborn library and the Matplot library over here. So first I'll type in import Seaborn as SNS. So to use Seaborn, you'd have to keep in mind that you'd also have to import Matplotlib, because Seaborn is a visualization library which is based on top of Matplotlib. And from Matplotlib, we are importing the PyPlot library. So PyPlot is a sub-module which is part of the Matplotlib library. And for Seaborn, we are giving the alias SNS, and for PyPlot, we are giving the alias PLT. Right. So now that we've imported this, what we'll do is we will go ahead and make a line plot for date and total cases. That is, we'd want to understand how are the total cases increasing date by date. So you see this particular command over here. So to make a line plot, we'll be using the sns.lineplot method, and inside this we are so as you see, we are mapping the date onto the x-axis, and we are mapping the total cases onto the y-axis, and the data which I'm using is India case. So this data set which I have, that is the data set which I'm taking over here. Three parameters over here: date onto the x-axis, total cases onto the y-axis, and the data set is India case. And over here, with the help of sns.set, I'm just setting the figure size over here. So 15 cross 10 would be the figure size, and I'm just plotting this method over here. So plt.show would plot the method. Now, since there are a lot of rows over here, this will take a couple of seconds for us to get the plot. So let's just wait a couple of seconds. Right, and this is what we get. So as you see, we have date on the x-axis, and we have total cases on the y-axis over here. And as you see, till here, so somewhere over here, this date. I see the date is not here because we have over 19,000 records over here, right? So for 19,000 records, we have this happening. So till here, it seems that the total cases are not exponentially increasing. But after this, there is a huge increase, right? There is a huge exponential increase, and now the total cases are more than 1,40,000. Now that is a cause for concern for all of us who are living in India. So we'd have to make sure that we are following the lockdown rules properly, right? So as you see, the curve is not at all flattening, but the curve is actually exponentially increasing. So all this talk about with the help of lockdown, we are trying to flattening the curve, but that is not the case which is happening over here. The curve is exponentially increasing, and we'd have to ensure our best that we are actually staying at our homes and we are not spreading the disease to others. Right, so now as you see, the data is not clear over here. So what we'll do is we will go ahead and just take a part of the data set. So I'd want to visualize only the last 5 days of it. So what I'll do is I will take India case.tail, which will give me the last 5 records, and I will store that in an object called as India last 5 days. Now similarly, I'll go ahead and make the same plot for India last 5 days. So I'll make the line plot. Here date is on the x-axis, total cases are on the y-axis, and the data which I'm using is India last 5 days. I'll click on run. Now I see this is a straight line, right? As you see, this was exponentially increasing, and this is a linear line. Now this seems to be even more dangerous, isn't it, right? So just in 5 days, as you see, this is a linear line like this. So over here, somewhere over here on 20th, the cases were 100,000, and on 24th, we have more than 130,000. This is truly a cause of concern, guys.
This brings us to the end of this course on predicting COVID-19 using machine learning. Thank you very much and have a great learning ahead.
Now our first task would be to load this dataset, and to load this dataset in R, we have a function called as read.csv. Now I'll just go ahead and use this command over here. I'll paste this, and with the help of this read.csv, I am loading the pokemon.csv file. This is the entire path. So basically inside this function, I am giving the path of this file, and I am storing this in a new object called as Pokemon, and let me just hit enter. Now I'll have a glance at this dataset, and to have a glance at the dataset, I'd have to use the view method. So inside view, I will pass in the Pokemon data frame. And now these are the different columns which are present over here. So we've got the abilities, which tells us about the abilities of the Pokemon. Then we've got against bug, against dark, against dragon, against electric, and so on. So these columns basically tell us how does a particular Pokemon perform against a bug type Pokemon. How does this Pokemon perform against a dark type Pokemon? Similarly, how does this Pokemon perform against a fairy type Pokemon? So these are some basic inferences over here. Then we've got the defense of the Pokemon. We've got the height of the Pokemon in meters, the HP of the Pokemon. Then over here, we've got the special attack, special defense, and speed of the Pokemon. Then we've got type 1 and type 2. So this type 1 is basically the primary type of the Pokemon, and type 2 is the secondary type of the Pokemon. And we've got weight in kg. So this tells us about the weight in kg of the Pokemon. And then we've got 7 generations of these Pokemon. And this final column over here is legendary. This tells us if the Pokemon is legendary or not. So this is some basic information about the Pokemon dataset. So now that we've understood this dataset properly, let me just go ahead and analyze this dataset. So I'd want to know how many rows and how many columns are present in this dataset. So to know how many rows are present, I would have to use the nRow attribute. And inside this, I would pass in the name of the data frame, which is Pokemon. And as you guys see, we've got 801 records. Or in other words, we have 801 Pokemons in total. And let me also check the number of columns. To check the number of columns, I'd have to use the ncall method. Inside this, again, I'll be passing in the Pokemon data frame. And as you guys see, we've got 41 columns over here. So we've checked the number of rows, number of columns, and now I'd also want to see if there are any missing values present in this data set. So to check if there are any missing values, we've got the s.na method. And inside this, I'll just pass in the Pokemon data frame. Now this gives us a bunch of true and false values. So this means that if there is a false value, then there is no null value over there. But on the other hand, if you find a true value somewhere, then it indicates that there is a null value present over there. Now what we have to do is we'll have to sum up all of the true values. When we sum up all of the true values, we'll get the count of total number of missing values in this data frame. So I would have to use this command sum. Inside sum, I'll use the method s.na, and inside that I'll pass in the Pokemon data frame. And as you guys see, we've got 138 null values present in this data frame. So this was some basic understanding of this data frame. Now that is clear, I'd want to understand some of the categorical columns over here. So I hope you guys know what is the difference between a numerical column and a categorical column. So when it comes to a categorical column, it basically consists of different categories. So as you see over here, we've got the type 1 column over here, and we've got different categories over here: grass, fire, water, and so on. Similarly, if I look at the is legendary column, you will have two categories over here, which are 0 and 1. Similarly, in the generation column, you will have 7 categories starting from 1 going on till 7. And when you talk about a numerical variable, so this what you see: SP attack, SP defense, speed, these are numerical variables because you just have continuous numerical values over here. Now, I'll be glancing at some of the categorical columns. So I'd want to know the number of types of Pokemons which are present. So type 1 would basically tell us the primary type of the Pokemon. So what I'll do is I'll use this method called as table. Inside this, I will pass in the type 1 column. So here I'll just give Pokemon $type 1, and this would give me the frequency of all of the different primary types which are present. So here, as you see, we've got 114 water Pokemons. So out of the 801 Pokemons in total, we've got 114 water Pokemon. So it seems that the maximum number of Pokemons are of water type. Similarly, if we look at this, we see that there are only 18 fairy Pokemons. And if you look at this, there are only 3 flying type Pokemons. So this is the minimum. So the minimum primary type, or the minimum number of Pokemons which belong to one particular primary type is flying. Similarly, if you look at this, we've got only 23 ice type Pokemons. We've got 52 fire type Pokemons, and let's look at grass. So we've got 78 grass type Pokemons. Right, so we're just trying to understand some important features of this Pokemon dataset. And now we've understood this. Now I'd want to know how many Pokemons belong to different generations over here. And for this purpose, I'll be passing in the generation column into the table method. So I'll use table. Inside this, I'll just type in Pokemon $generation. And as you see, we've got 7 generations of Pokemons. And most of the Pokemons belong to the 5th generation. So we've got 156 Pokemons belonging to the 5th generation. And we've got the next highest is the 1st generation. So we've got 151 Pokemons belonging to the 1st generation. And the least, so the least which you see is the 6th generation. We've got only 72 Pokemons which belonging to the 6th generation. So again, a very interesting observation over here. Right, so these are the sort of inferences which we are trying to draw from this Pokemon data set. Now I'd want to know what is the frequency of number of Pokemons which are legendary and which are also not legendary. And that is why I am passing in the S legendary column into this table method over here. So 0 over here indicates that the Pokemon is not legendary and 1 over here indicates that the Pokemon is legendary. So from this we see that out of the 801 Pokemons, 731 Pokemons are not legendary and it's only 70 Pokemons which are legendary over here. So there are very few legendary Pokemons present. Again, a very interesting observation. So now that we have glanced at some of the categorical columns, let's understand some numerical columns over here. So we've got different numerical columns present in this data set. Now out of the all of the numerical columns, I'd want to understand the special attack column. So I'd want to know what is the minimum special attack of a particular Pokemon. So for that, I will use the min method, and inside this, I'll just use Pokemon $SP attack, and this is how I'm trying to find out the minimum value of special attack, and we see that the minimum value of special attack is only 10. Now similarly, let me find out the maximum value of special attack. So to find out the maximum value of special attack, I'll use max function, and inside this again I'll pass in the Pokemon data frame, and using the dollar symbol I'll select the column, and the column is again SP attack, and we see that the maximum special attack of a Pokemon is 194. It's interesting observation over here. So minimum special attack of any Pokemon is only 10 and the maximum special attack of a Pokemon is 194. Now similarly, I'd want to know the minimum and maximum values of HP of a Pokemon. So here I'll type in min, and I'll pass in the Pokemon data frame over here, and using the dollar symbol I will select the HP column. And we see that the minimum HP of any Pokemon is 1. And let me also find out the maximum value of HP. So here I'll use max method and I'll pass in Pokemon, and then I'll use the dollar symbol, I'll select the HP column over here, and as you guys see, the maximum value of HP is 255. So now that this is done, what I'd want to do is I'd want to rename some of my columns over here. So as you guys see, I've got these two columns over here. I've got type 1 column and type 2 column. Now this is not actually right. So type 1 has to be the primary type. It has to be renamed to primary type, and type 2 has to be renamed to secondary type. So let's go ahead and do that. So for that purpose, we have this command over here. Let me just go ahead and paste it, and let me explain what is happening over here. So we have this method called as call names. Now I'll just cut everything over here, and let me just print out call names of Pokemon. So when I print out call names of Pokemon, this gives me the list of all of the column names which are present in this data frame. Now that this is done, what I'll do is I am checking call name of Pokemon is double equal to type 1. And here I have a bunch of false and true values, and I have a true value only in that case where the column name is equal to type 1. Now with the help of this entire command, what I'm doing is, let me just copy this again and paste it over here. So what I'm doing is, from this all of the column names, wherever the column name is equal to type 1, I am changing the name of that column to primary type. So this is what we are doing over here. Now let me have a glance at the Pokemon data frame again. I'll type in view of Pokemon. Now let me have a glance at this. So as you see, initially the name of this column is type 1. Now we have successfully changed it to primary type. Similarly, we've got the type 2 column. Let's go ahead and change the name of that column to secondary type over here. So as you see, call names of Pokemon, we've got type 2 over here, and I'd want to change the name of this from type 2 to secondary type. So this is what we are doing. And I'll just have a glance at this again, view of Pokemon, and let's see what is the result over here. I'll just drag this to the end of this data set, and as you guys see, initially the name of this column was type 2. I have successfully changed this to secondary type. So we have done the basic pre-processing over here. Now we'll go ahead and start our first task. So our first task is to catch some grass type Pokemons. Now, when I say that we'd have to catch some grass type Pokemons, what I basically mean is we'd have to extract all of the grass type Pokemons from this primary type column. And to do that, I would need this library called as deployer. So the deployer is a package in R which should help us to do some basic data manipulation. So here, I'll go ahead and write this command. So first I'd have to give in the name of the data frame, and from this data frame, I'm using the filter method. The filter method is a part of the deployer library. So I'm using this filter method to extract only those Pokemons whose primary type is equal to grass, and I'm storing all of those Pokemons in a new data frame called as grass Pokemon. So I'll repeat this command again. So this, what you see, this is known as the pipe operator, and this pipe operator helps us to connect different data sets or different functions together. So here we are connecting this Pokemon data frame with the filter method. And from this Pokemon data frame, we are filtering out only those Pokemons whose primary type is grass, and we are storing the result in this object called as grass Pokemon. Now we've done that, I'll go ahead and have a glance at this. So I'll use the view method, and inside this I'll pass in grass Pokemon. So we see that there are 78 grass Pokemons in total. Out of the 801 Pokemons, we've got 78 grass Pokemons. And let me look at the primary type. So as you see the primary type over here, so you see that all of these are only grass type. So an interesting observation over here again. Right, so we have extracted this grass type Pokemon over here. Now that this is done, I would have to perform some basic inferences on this grass type Pokemon. So what I'm going to do is I'd want to understand the minimum and maximum speed of a grass type Pokemon. So here I'll use the min method again. I will pass in the grass Pokemon inside this, and let me check the speed of it. So minimum of grass Pokemon $speed, and I see that the minimum speed of a grass Pokemon is only 10. Similarly, I'd want to check the maximum speed of a grass Pokemon. So here I'll pass in grass Pokemon $speed, and I see that the maximum speed of a grass Pokemon is 145. So let me add this as a comment over here. I'll use hash, and the minimum speed is 10, and the maximum speed of a grass type Pokemon is 145. I'll also go ahead and add that. Now similarly, I'd want to check the average value of special attack and special defense for a grass type Pokemon. And to check the average value, I'd have to use the mean method. And inside this, I'll pass in grass Pokemon $special attack. And the average value of special attack for a grass type Pokemon, it comes out to be 74. So let me just add in 74 over here. Similarly, I'll also check the average value for special defense. So grass Pokemon $special defense, and we see that this comes out to be 69. I'll also add 69 over here. So we have glanced at some basic information of the grass type Pokemon. Now it's time to visualize some stats of the grass type Pokemon. So here I'd want to understand the distribution of HP. So HP is basically hyper power of a Pokemon. So I'd want to understand the distribution of hyper power of a grass type Pokemon. And what we'll be doing is we'll be using the ggplot2 library to make this visualization. So I'll have to load this library. So here I'll type in ggplot2, and we have loaded this library over here. Now to actually understand the distribution of this HP column, so let me just check. So as you see, this is the HP column, and this is a numerical type of column. And we've understood in the previous sessions that if it's a numerical column, we use a histogram, and if it's a categorical column, we use a bar plot. And since this is a numerical column over here, I will be using a numerical column. So my first task would be to use ggplot, and I'll go ahead and map the Pokemon data onto the data layer. So let me hit enter. As you guys see, I have mapped the Pokemon data frame onto the data layer. Then I'd have to map the column onto the X aesthetic. So I'll add the aesthetic layer over here, and onto the X aesthetic I will map the HP column. Going ahead, I'll use a geometry, and the geometry which I'm using is geom histogram because I don't want to make a histogram obviously, and since this is a numerical column, we have to pick a histogram. And this is what we get over here. Let me zoom this and let's see the distribution of the HP of a grass type Pokemon. So as you guys see, we've got around, so this count is for the number of Pokemons present. So as you guys see, we have around close to maybe 140 Pokemon. So there are around 140 Pokemons whose HP would be around 60, right? And similarly, there would be around 55 odd Pokemons whose HP would be close to 100. And there are very few Pokemon. So maybe there are just 2 or 3 Pokemons whose HP is greater than 200. Now, when you talk about this, we are talking about grass type Pokemons. So we have only 2 grass type Pokemons whose HP is greater than 100. Similarly, there are only 140 grass type Pokemons whose HP would be around 50 to 55. And there are around 55 odd grass type Pokemons whose HP is around 100. So that's an interesting observation over here again. But what you see, this plot is very bland. Now, if I want to go ahead and add a color to this, I have an attribute called as fill. And for this fill attribute, I will use pale green 4. And as you guys see, I have successfully added this color over here, which is pale green 4. Similarly, I'd want to understand the distribution of the height of grass type Pokemons. So again, I'd have to go ahead and make a similar plot. So ggplot. Onto the data layer, I'll be mapping the Pokemon data frame. Then I'll have the aesthetic layer. And onto the X aesthetic, this time I'd have to map the height M column, which is basically height of the Pokemon in meters. And again, I'd have to make a histogram. Since I'd have to make a histogram, I'd have to use the geom histogram method. And as you guys see, I have made this histogram over here again. Now let me zoom this, and as you guys see over here, the height it varies from 0 to around 15 meters. So when you talk about grass type Pokemons, there is only one grass type Pokemon whose height is very close to 15 meters, and we'll have around 3 grass type Pokemons whose height is maybe 8 or 9 meters. And most of the Pokemons, so we've got around maybe 200 or more than 200 odd Pokemons whose height is around 1 meter or less than that. So that again is interesting observation. So here we've actually made a mistake. So we've plotted just the Pokemon data frame. We have to plot the grass Pokemon over here. So let me go ahead and make this as grass Pokemon. Right. Now this is the actual distribution of a grass type Pokemon. So we see that there are around the maximum height of a grass type Pokemon is actually only 3.5 meters. This again is very interesting. And most of the Pokemons there, as you see, most of them are concentrated over here. Most of the grass type Pokemons, again, their height is less than 1 meter over here. So interesting observation again. Now we'll go ahead and understand how many of the grass type Pokemons are legendary and how many of the grass type Pokemons are not legendary. And for this purpose, we'll be making a bar plot. So ggplot again, and onto the data layer, I'd have to map the grass Pokemon, and I'll use aesthetic layer over here, and onto the x-axis, I'll be mapping this legendary column, and the geometry which I'll be using is geom bar. Again, a very interesting observation over here. So the 0 indicates that the grass type Pokemon is not legendary, and the 1 over here indicates that the grass type Pokemon is legendary. And we see that there are 70 odd Pokemons or close to 70 odd Pokemons which are not legendary, and there are very, very few Pokemons, maybe around 5 or 6 Pokemons, 5 or 6 grass type Pokemons which are actually legendary. So all of this was about grass type Pokemons. Let's go ahead and catch some fire type Pokemons. So when I say let's go ahead and catch some fire type Pokemons, what I mean is we'd have to extract fire type Pokemons out of the original Pokemon data set. So I'll have view and let me type in Pokemon over here. Let me look at the primary type. And if I look at the primary type, as you see, we've got all of these different levels over here. Now all of these different levels, I want to extract only those Pokemons where the primary type is equal to fire. So this would be the command for that. I'll have Pokemon. I'll use the pipe operator over here. Let me type in the filter command. So the filter command is part of the deployer package, and inside this I need to give in the condition, and the condition is the primary type needs to be equal to fire. And I'll go ahead and store this in a new object, and I'll name that object to be fire Pokemon. And I'll have a glance at this view of fire Pokemon, and as you guys see, we've got 52 fire Pokemons in total. So out of the 801 Pokemons, we've got 52 fire Pokemon. So that's actually very less. Now let me see the primary type. So if you see the primary type, you see that all of the values are fire, because this was the condition which we had given while extracting the data sets. Right, so we've got this done. Now we are going to do a similar sort of analysis over here. So first we'll start up by understanding the minimum and maximum value of a fire type Pokemon. So I'll use the min method over here, and inside this I'll pass in Pokemon. So Pokemon dollar, this has to be fire Pokemon actually. So minimum value of fire Pokemon. Minimum, I have to check the speed. So minimum speed of a fire type Pokemon is 20. Let me just add a comment over here. So minimum speed of a fire type Pokemon is 20, and similarly let me check the maximum speed. So here I'll have maximum of fire Pokemon dollar speed, and we see that the maximum speed of a fire type Pokemon is 159. Now let me go ahead and compare the speed of a fire type Pokemon with that of a grass type Pokemon. So here, as you see, the minimum and maximum value of a grass type Pokemon, the speed of a grass type Pokemon are 10 and 145. This is 20 and 159. So it seems that in a general case, if we take only minimum and maximum value, it seems that the fire type Pokemons might have a higher speed when compared to the grass type Pokemons. So an interesting observation over here, isn't it? Now let's go ahead and do some more inference on our fire type Pokemons. So we have found out the minimum and maximum speed of the fire type Pokemons. Now what we are going to do is we are going to check the average value of special attack and special defense for fire type Pokemons. And to check the average value, we already know that we'd have to use the mean method, and inside this I'll pass in fire Pokemon dollar SP attack, which will give me the average value of special attack, which is 87. Similarly, let me check the mean value of special defense. So I'd have to use mean. Inside this, I'll pass in 5 Pokemon dollar SP defense, and as you guys see, the average value of special defense, it comes out to be 71. So we've got 87 and we've got 71 over here. Now let me again compare this with the grass type Pokemon. So the average speed for a fire type Pokemon was 87, and the average attack for the grass type Pokemon is 74. So again, it seems that a fire type Pokemon has in general has a higher special attack when it's compared to a grass type Pokemon. Similarly, when we compare the special defense of a fire type Pokemon with a grass type Pokemon, it seems that the fire type Pokemon has a higher value of special defense. So this is an interesting observation over here again. Now we are going to do some visualization on top of the fire type Pokemon to understand some of its stats. So I'd want to understand the frequency of the number of fire Pokemons belonging to different generations. And for that purpose, I'd have to make a bar plot, and I'll be mapping the generation column onto the XY static, or in other words, I want to understand the number of fire Pokemons belonging to different generations over here. So ggplot. This time onto the data layer, instead of mapping the grass type Pokemon, I'll be mapping the fire Pokemon over here, and on the aesthetic layer, I'll be mapping the generation column onto the X aesthetic. And finally, I'd have to make a bar plot, and to make this bar plot, I'll be using geom bar. And when I hit enter over here, I've got all of these bars. So as you see, we've got 7 generations in total. So 1, 2, 3, 4, 5, 6, and 7. And it seems that most of the fire type Pokemon, so it seems that we've got Pokemons which belong to generation 6 to generation 4. So again, this is an interesting observation over here. Right, so now that we have this ready, what I'm going to do is I'm going to understand the frequency of the secondary type of fire type Pokemons. So again, I'll have ggplot over here, and onto the data layer, I'll be mapping fire Pokemon. Then onto the aesthetic layer, I'll be mapping the secondary type column. This actually would go on to the x-axis. So on to the x-axis, I'll be mapping the secondary type column. And again, the geometry which is used by me is geom bar. Let me go ahead and hit enter over here. So seems like I have given a space over here which shouldn't exist. Right. So this again is an interesting plot over here. So as we see, most of the Pokemons, when it comes to fire type, so we've got around 22 odd Pokemons, and these 22 odd Pokemons, they don't really have a secondary type over here. And the next highest is fighting and flying. So it seems like most of the low over here. So as you see, dark, dragon, fire, psychic, rock. So the secondary type of these is very low over here. So this was secondary type. Now so this time I'm going to make a scatter plot. So my first task would be to map the fire Pokemon data frame onto the data layer. Now in the aesthetic layer, I'll be mapping the SP attack on the x-axis. So I have SP attack on the x-axis, and I'd have to map the SP defense onto the y-axis. So I'll have SP defense over here. And since I want to make a scatter plot, I'll be using the geom point method. And let me zoom this over here. So as you guys see, if the special attack of the fire type Pokemon is increasing, the special defense of the fire type Pokemon is also increasing. So you can say that there is sort of a linear relationship between the special attack and special defense of this fire type Pokemon. Right, so that's, if you take this, there is just one Pokemon over here whose special attack and special defense is very, very low. Right, so this is the only Pokemon whose special attack is only fire type Pokemon whose special attack is less than 40. And again, if we take this particular Pokemon over here, so it seems that there's one fire type Pokemon which has the highest special defense, and this comes out to be around maybe 135 or close to 135. And over here, the special attack value would be close to around 110 maybe. So this again is an interesting observation over here. So this was with respect to special attack and special defense. Now we've got a few more visualizations to do, but we'll just directly head on to water type Pokemon. So let's go ahead and catch some water type Pokemons now. And for this purpose, I'd have to extract all of those Pokemons where the value is water in the primary type column. So first I'll start off by giving the name of the data frame, which is Pokemon, and then I'll use the filter method from the deployer package. Inside this, I'll set the primary type, and this primary type has to be equal to water, and I will store this in a new object, and I'll name that object to be equal to water Pokemon. So I have extracted the water Pokemon as well. Now I'll have a glance at all of these water Pokemon. So view of a water Pokemon, and as you see, I have extracted all of the water type Pokemons over here. So we've got 114 water type Pokemon. So out of the 801 entries, we've got 114 water type Pokemons. And as you see, the value in this column, all of the values are only water. So now that we have extracted the water type Pokemons, let's do the same analysis over here, because I'd want to compare the speed, special attack, and special defense with respect to fire and also grass type, I'd want to check the minimum and maximum value of speed. So minimum water Pokemon $speed, and we see that the minimum speed of a water type Pokemon, it comes out to be 5. And also let me check the maximum speed. So here I'll have max water Pokemon $speed, and we see that the maximum speed of a water type Pokemon, it comes out to be 132. Let me compare this with fire type and grass type. So 5 and 132. So seems that water type Pokemon's minimum and maximum speed is less than fire type. Let me check it with what else have we got? We've got grass type over here, and again the minimum and maximum is less than the grass type Pokemon as well. So it seems that the water type Pokemons normally are very slow when compared to grass type and fire type Pokemons. So this is something to ponder upon. Now we've found this out. Now what I'm going to do is I will similarly check the average value of special attack and special defense for a water type Pokemon over here. And inside the mean method, I'll have water Pokemon. So water Pokemon $special attack. And it seems that the average value for special attack of a water type Pokemon is 74. And similarly, if I want to check the average value for special defense, so water Pokemon $special defense, this comes out to be 71. And let me check this with respect to grass and fire again. So 74 and 71. So the special defense is same with respect to fire Pokemon, but the special attack is lower when compared to fire. And here, so this was 74. So 74, the special defense is same with respect to grass, and the special defense is actually more when compared to the grass type Pokemon. So this again is an interesting observation over here. Let me go ahead and complete the rest of the stuff over here. So we are done with the basic analysis of it. Now I'd want to visualize some stats of a water Pokemon, and I'd want to see how do these water Pokemons perform against ice type Pokemons. So here I've got the against ice column. Let me show you guys the against ice column. This is the column, and what I'm going to do is, since this is actually a continuous numerical value, I'm going to make a histogram for this. So I'll have ggplot, and this time onto the data layer, I'll be mapping the water Pokemon, and onto the aesthetic layer, I'll be mapping the against ice column onto the X aesthetic, and I'll go ahead and make a histogram out of this. So here I'll use geom histogram, and as you guys see over here, so it seems that we've got around 80 odd water Pokemons whose their rating against ice is 0.5, and there are very few Pokemons. There are only around 20 odd water Pokemons whose rating against ice is 1. Now similarly, let me check the rating of water type Pokemons against poison type Pokemons. So the command would be same, it's just that instead of mapping against ice onto the X aesthetic, I am mapping against poison onto the X aesthetic over here. So seems like we have got an error. Let me see what exactly is that error over here. Water Pokemon against poison, we have geom histogram over here. What I'll do is I would have to type ggplot over here. Right, so it seems that water type Pokemons are better against poison type Pokemons. Now let me compare this with ice. So as you see, with respect to ice type Pokemons, so most of the Pokemons, their average rating was 0.5 against ice type, and over here as you see, most of the water Pokemons, their rating against poison type is 1. And finally, let me see how do these water Pokemons perform against grass type Pokemons. So this time I'll be mapping against grass onto the X aesthetic. and we see that the rating is 2. So we've got 80 odd Pokemons over here this time. So we've got 80 water Pokemons whose rating against grass type is 2, and we've got around 20 odd Pokemons whose rating against grass type is 4. So it seems that the water type Pokemons, they perform very well against grass type Pokemons. That's an interesting observation over here.
If I take an example of before we used to handle our data using Excel or some other tools, but that time what we have, that time used to have structured data, right? Structured and a very less amount of data. And anyway, every company used their past data. But in this scenario, in today's world, each and every company is basically generating data every moment. So when I'm saying that every company is generating data in every moment, why I'm saying that? Suppose you are booking a cab or you want to order your food. That time you will give your data to that company particularly, and they are going to take your data. Okay, and based on your data and all the customer they have, they are going to store that and they are going to try to focus their business. So in this case, when they are generating this data has become very much unstructured or semi-structured. That time using Excel or some basic tools is not able to handle this huge amount of unstructured data. So in that time, we need to have a solution. And data science came into the picture in that time, right? So data science have lots of tools that actually help us to handle our unstructured or semi-structured data. In today's world, these data science tools are helping us to handle those data, to get the insight from those data, right? So now we will have a look at what is data science. Data science is a particular tool or an algorithm or a particular process. So data science is a process to get some meaningful information from the massive amount of data. In simple terms, you can say you just can read and study your data to get a proper intuitive, right? And machine learning, deep learning concepts we have to discover those hidden patterns from the raw and unstructured data. Okay, so this is what data science stands for. So now we will have a look at what's the life cycle of data science. So basically, before doing the project using data science concepts, I just want to give you a proper insight that why we are using data science and what are the steps you need to follow when you go for making any project on data science. So basically, the first step you need to do whenever you are going for any project, you need to understand the business problem. So what problem you are like right now we are facing. So in my case, I am going to take a credit card fraud analysis case scenario, right? So there are lots of companies like Zomato, Uber, Ola, like almost every website or e-learning or any company, right? They are using payment method as a online transaction. So when the online transactions are increasing, the number of fraud online transactions is also increasing. So this is something that this is proportionally related, right? Whenever we are going to do any online transaction, there is a chance that there should be a hacker who is going to hack your account details, and they are going to take the advantage of that, and they are going to actually hack your account. So in that case, if you, in order to solve those problems, in order to understand that what's the scenario and what's the attributes actually affecting the transaction, that you can say, okay, this is a fraud transaction and your bank will actually block that transaction, right? So this is my scenario, and this is I'm talking about this project particularly. In this project, this is the business problem. In order to solve them, what we need to do, we need to collect the data. So collecting the data is basically you need to collect data to analyze the problem. So for my case, I collect the data from table. So if you have some other options to collect the data, or if you have your own company where the people are actually doing their online transaction, you can take those data. So basically, data acquisition stands for you need to collect the data to analyze them, right? Then comes the data cleaning part. This is the most time consuming part when we go for clean our unstructured or semi-structured data. Then what we need to do, we need to clean our data. So in that unstructured data, we need to maybe handle our missing values. We need to handle misspelled attributes. Maybe you have some there is no point of having the attributes in your data, right? So in those things you need to solve using data cleaning. So this is the most time consuming and time taking part, you can say. When your data is clean, you can say maybe 50% of your job is done. Then you need to go for exploratory data analysis. So exploratory data analysis stands for EDA, right? We all quite familiar with the term of EDA. But what is EDA? EDA is basically statistical. It uses a statistical concept. So why do we use stats in the data science, right? So basically we need to use stats to understand our data. What's the state of your data? How your data is working, right? So these all the factors we can understand by looking at the stats of my data. So this is why we need to use EDA technique. Now, when you have a proper idea of your data, that how your data is behaving, what are the hidden patterns you have in your data, so in that case, you need to already know what type of algorithm will suit your data, right? So you can use the machine learning algorithm to build your model. After building your model, you can give enough data to train your model, but you need to predict your model, right? Whenever you are going to give an unknown data to your model, how it's gonna work. So in that case, the predicting part is the most hectic part to understand how your data, how your model is working. So when you see with the unknown data also, your model is working perfectly. That time you can say, okay, my model is ready. Now we can maybe deploy our model. So this is the whole scenario for a data science. Okay. We will have a look at what is Python. So I know you guys all have a little bit of idea about Python, right? So Python is basically a popular high-level and object-oriented and interpreted language, right? So it's it's very favorite language for me because this is very beginner-friendly language, right? And you don't need to go for doing lots of syntaxes, lots of lines of code. You don't need to do that. And it supports, and it has like amazing libraries you can go for, right? Now we'll have a look at history of Python, how Python came into the picture. So by Rossum in 1989. Python came into the picture, and this is invented by Rossum. Rossum used to love watching comedy movies from late 17th, and he needed a short, unique, and slightly mysterious name for his language. And that time he was watching Monty Python's Flying Circus, and from that series only he said, okay, maybe my language name can be end up using Python, and this is how Python invented. Now let's have a look at why Python is so popular. Python is so popular because of its robust community, open source, easy to learn, and supports automation. And the main big thing, the Python is so popular because it supports big data, machine learning, deep learning, and cloud computing, right? And it has a huge number of Python libraries and frameworks too. Now we will have a look at how can you install Python. So doing the project, you need to install Python to your local system. How can you do that? Please go to Python.org, their official official site, and from there you can install Python directly, right? Now I'm going to show you some of the IDE you can go for. We have some integrated development environment. Basically, it helps you to code in Python, right? You don't need to take care of all the indentation and all. That's one thing you need to understand in Python. So Python is one of the most used IDE. And before installing IDE, be sure Python is already there in your system. Otherwise, IDE will not support it, right? Then we have IDE for Anaconda, right? The Anaconda is known as data science toolkit. You can go for that as well. Now we are going to say Google Colab. I am going to use Google Colab in my session because this is one of the most easily useful IDE, and you don't need to install anything to your system. Okay, I am saying repeating that, guys, that if you need to have the data set, you need to go to Kaggle directly. It's it's open source and directly available from Kaggle. Now we will have a look at how can you start with Python, and we will go to our notebook. But I will show you how can you guys actually start off with Google Colab, right? So, how can you start the Google Colab? Write Google Colab on your favorite browser. Then, you will get the first link, right? You just need to click on that. And there, just need to write a new notebook. This is how you need to start your notebook to do the coding, right? So, this is very simple. You don't need to do anything. And if you want to change your notebook name, you can change from here. So, you can see for my case, it's Untitled 522. can change it to demo, right? So this is how you can change the name. So this is very simple to work with, right? Now we will have a look at that basic library we have in in Python, right? What are the basic library do we have? We have NumPy and pandas. I already told that NumPy is a library that we use for mathematical calculation, and we use pandas for manipulating our data. So here you can see, if you need to install NumPy, you need to write pip install NumPy, and your NumPy will be installed. For the case of Google Colab, this is already pre-installed, so you are getting already satisfied. So how can you import a NumPy? So importing NumPy, you need to write import NumPy as NP. So why we are using this as NP? This as NP is basically stands for the alias name, right? What is alias name? Basically, it's a nickname for your particular library, right? If you don't use NP, then every time you are going to call any function from that library, you need to write NumPy, right? So this is long, so for that I just gave a alias that as NP. If you want to put one character alias, you can go for doing that, right? Now I'm going to create a single array. So first I'm going to show you some basic parts of NumPy and pandas, and then we will move into the project. So yes, you can do that. You can upload your ipynb file. So Google Colab does not support .py file, so you need to have .ipynb file. Fine. Now what we need to do, I am going to make an array of it. How can I do that? To do that, we are going to use np.array, right? So we are going to use np.array function to create my first array. Okay. So in this case, I just call the function and then I am providing my data. What is my data? My data is 789, right? So I have provided one-dimensional data which have the elements of 789, right? Let me just print that. You can see my first single dimensional array is ready with 789. Okay. Now we will have a look at the multi-dimensional array. How can I do that? For multi-dimensional array, you need to provide each dimensional element. For my case, you can see 8, 9, 10 is my first dimension and 11, 12, 13 is my second dimension. So this is how I mentioned my dimension. So here my dimension is 2. But in that case, if you want to check, I am saying my dimension is 2. But if you want to check some big array, you have a big array, you don't know that what are the elements and what are the dimension that particular array has. To check that, you need to use .endim function, right? So that .endim function will return you what's the dimension of your array. Okay. So for the first case, single array should have a single dimension. You can see this is 1. But for the multi-dimensional array, it should be 2. So this is how you can get the dimension of your array. So here you can see these are the basic terms, basic functions we have. If you want to check the type of the array, you can use .dtype function, right? So now if you want to check the size of the array, okay? So basically what is that size stands for? This size is going to show you what's the how many elements you have in your array, okay? So this is how we are going to use the basic parts of the NumPy, okay? So you need to have a good idea about array when NumPy is basically manipulating arrays and mathematical implementations, right? Now if you want to reshape your array, how can you do that? Using .reshape function. So basically .reshape function helps you to say, okay, from 2-dimensional to I want my array should be 3-dimensional, right? So in that case, I am going to put the first parameter is how many, what's the dimension you want for your particular array, and then you need to put the parameter how many elements you want in particularly per dimension, right? So in that case, you can see I want a 3-dimensional array with at least 2 elements in my each dimension. So you can see my output is 8, 9, 10, 11, 12, 13. Now we are going to go for, these are the basic part I know. Now we will go for pandas. How can you install pandas? So for installing pandas, you need to write again pip install panda, and importing panda is same as NumPy, that import pandas as pd, right? Now here is a concept called data frame. Okay, so when we are going to use our credit card fraud analysis, we are going to store our CSV file in a data frame. So data frame is basically a tabular format, right? In that data frame, you can store your data. Okay, so here I have some of the built-in functions. We have dot head that will return you first 5 rows of your data set. Then we have dot tail function that will give you the last 5 rows of your data set. Then we will show as a shape, right? What is shape? So it will give you what's the data set, what's the structure of your data, how many rows, how many columns you have. So most of the cases we are going to use comma separated value. Now what we need to do, we need to import our libraries, that pandas and numpy. You can see we are going to use pandas and numpy. And we are also going to import matplotlib for data visualization. We are going to use scikit-learn. That scikit-learn is basically we use for machine learning purpose, right? And then what we need to do, we are going to import all the scikit-learn parts. Okay. Now already you can see this is my link, right? Fine. Now what I did, already I have uploaded my data. Now what I need to do, I need to go for reading those data. So reading those data using pandas, we need to use read CSV function, right? From there, I need to give the path of that file that contain credit card to CSV. Okay, let me just do that. So what is contains? So this data set contains 285000 rows. Okay, and we have 31 columns. In those columns, what we have, the important columns in time, amount and class. Okay, we are going to use dot head, right? So basically we are going to use dot head to get the first 5 rows from your data set, right? So this is our data set. You can see we have time and this many columns. Now if you want to see the shape of the data set, that how many rows and how many columns you have, you need to write dot shape function. Now I am going to use dot describe. What is this dot describe stands for? So this dot describe is basically going to give you some of the statistical measurements, right? What's the count of your data? What's the mean, median, and standard deviation for your data set? Now comes the IQR, right? Interquartile range. That is for 25%, 50%, and 70%. So basically, this will help you to understand your data set more deeply. So over here you can see we are going to take the description for amount, time and class. Okay, so these are the basic main columns we have in our data set. Now if you want to see how many columns you have in your data, you can use dot columns function. Okay, now as we are talking about the unstructured data, so first we need to go for checking our data. Okay, my data is unstructured or structured, or how many null values I have in our data set, because we all know making model with null values, that cannot give you a good prediction. So always we try to remove null values from our data set, or to replace those null values with some other zero or nan, something like that. So to check the nan value in your data set, you need to use dot isNA function, right? But why I use dot any? So basically dot isNA is going to give you a boolean value. Okay, so when you're going to have a boolean value, that time what you will get for each and every row and column, you are going to get this boolean value. But I want to see for each and every column, if there any nan value, let me show that. Okay, so in that case, I say dot any. Dot any is basically if you have one nan value also, it is going to give you true, right? So in that case, this is how you can check your data set. You can see for my cases, there is no nan value. So I can say my data is well prepared. I don't need to check, or I don't need to do lots of things to understand to change our data to use my data. But most of the cases, you have data where you will have lots of nan values, right? So in there are lots of functions you have in Python who will help you to handle those. Now what I need to say, I'm going to check the null value with a percentage. So here I just use the percentage formula over here, right? And I said, okay, is there any percentage? What's the percentage of null value I have? This is the rechecking. So you can see I have 0%. Okay, so I can say my data is good to go. Now I want to see the class. So what is class? Before going to class, we need to check some of the machine learning concepts as well. But in that case, now in my data, I want to see how many of my data transaction I have in my data set which is fraud transaction, and how many data sets I have which are not a fraud transaction, right? In order to understand that, you need to have an idea about machine learning. So let's go and check what is machine learning and what's the technique we are going to use. So what is machine learning? So for my cases, if something came for machine learning, maybe I start thinking like when I didn't know the concept. So maybe I used to feel like, okay, machine can learn it like by itself, right? So machine learning is a subfield of artificial intelligence. So artificial intelligence is the umbrella, and under that we have lots of subfields. And that subfield, one of the subfield is machine learning. That allows a system to automatically learn and improve from experience without being explicitly programmed, right? So this is the definition of machine learning. So what is traditional programming? So in the traditional programming, what we need to do? We need to give our input, we need to program for that, we get the output, right? We all familiar with that. But every time you give new data, you need to write a code. But for the machine learning, you need to provide the data, you need to train your model, you need to make a model, right? And you will get the output. But when in the next time you are going to give the data to your model will work for you. You don't need to write a code from the scratch. So this is the basic difference between traditional programming and machine learning. Okay, and in this case, it's going to reduce the human efforts, right? If something I know that credit card fraud analysis model is ready, for the each and every time, I don't need to make a model for that, right? So what I need to do, I need to provide the new data to my model, and my model will say this transaction is a fraud or this transaction is a genuine transaction. So this is the help of machine. When you have a lot of data or already you have a model that is trained, it's like you don't need to go for doing anything. You just need to provide that new data to your machine, right? Now, there are the types of machine learning we have. So, we have supervised learning, we have unsupervised learning, and we have reinforcement learning. So, I will give you one-liner of what the types of what this stands for, right? From the supervised learning itself, you can understand that there is a supervisor or a teacher, right? Okay, so basically supervised learning is work as a supervisor or a teacher. But this teacher or a supervisor is basically your class. If you can remember, in the data set we get our outcome, right? So that outcome is our class basically, right? We teach or train our machine with label data. Okay, we teach our model with label data. So that label is basically the classes. And when you have that teacher with your data, so that time we can use the supervised learning technique. So supervised learning technique is basically you need to provide a teacher with your data to learn your model. Okay. Then when we are going to check our data set, we need to give the test data. But when we are going to provide the test data, we are not going to provide that particular class. So basically your model task is to find the outcome, to find the class, right? So like suppose we have a credit card fraud analysis project. So there what we need to do, we need to check that particular transaction is like fraud or genuine. So you have the attributes, right? Whenever that particular transaction is a fraud transaction, you have the attributes, the data. Lastly, you need to classify those data in a class, that if it's a 0, if I'm going to say it's representing a 0, maybe your transaction is a fraud transaction or is a genuine transaction. When I'm going to provide this your class as a 1, I said okay, this is a genuine transaction, right? So this is how we provide mention a class for a particular data set, and those classes basically helping us to teach our data, to teach our model. In the supervised learning, from the label data and applying the knowledge to predict the level of the new data, right? And we have some of the supervised learning techniques like linear regression, logistic regression, decision tree, random forest, and naive Bayes. Now, I will give you one line that what is unsupervised. Unsupervised learning is basically from the picture itself, you can see. Okay, so basically in the unsupervised learning case, machine starts learning from itself. There will be no label data, there will be no teacher for your model. Your model starts learning by itself, right? So this is the difference between supervised and unsupervised learning. Now comes the reinforcement learning. What is this reinforcement learning stands for? So basically reinforcement learning is when your model is going to predict rightly, you are going to give a reward. But when your model is going to predict wrongly, you need to give a penalty to your model, right? So this is how our reinforcement learning works, right? Now we will have a look at what is logistic regression, because at any way we are going to use logistic. But why logistic regression, right? So when your data is divided into two parts, right? When you have a data with the classes, right? 0, 1, right? Yes, no, true, false, okay? Men, women. So that time these data are known as discrete data. And this data, to analyze this discrete data, you need to use logistic regression concept. For linear regression, you should have a continuous value, right? You will not have 0, 1, true, false, okay? You do have some labels, but those labels are a continuous level, right? Continuous value. Now, the logistic regression is also part of supervised learning classification. It's used to predict the probability of a target variable, and the nature of the target or dependent variable is discrete. So, for the output, there will be only two classes will be present, that I said already. The dependent variable is a binary in nature, so can be it 0 and 1, yes, no, true, false, like this. So in logistic regression, we have a function called sigmoid function. In this function, we are going to use to make our ACE curve. There is a curve in logistic regression. This is known as the ACE curve, and that curve is actually made by sigmoid function. That is 1 by 1 plus e to the power minus value. I think you guys understand the concepts of machine learning and logistic regression. Now we can implement them in the actual data set. Now what I am going to do, I am going to write a for loop over here, right? So in this for loop, I said if my class, right? So if you guys can see over here, right? Let me just go up. You can see, yes, you can see there is a column called class, okay? Let me go up. Okay, so in this you can see we have a column called class. So in class, what we are going to check, this class is basically our label. That 0 is for what? 0 is for the not fraud transaction or genuine transaction. 1 is for the fraud transaction, right? So I am going to use a simple for loop that whenever my data is equals to, my class is equals to 0, I'm going to count that, and I'm going to say, okay, this is my, the number of, I'm going to use this, you can see over here, the normal average formula that, okay, the percentage of fraud transaction, not fraud transaction in my data set, or the genuine transaction. If you can see over there, you can see 99.8% data I have, that is basically a genuine data set. So I have very few data that is our actual fraud transaction, right? Now, the same thing I did for the fraud transaction as well, that I take that if my class equals to 1, then please add them, and lastly I am going to take the average of that, okay? Now, what I am going to see, you can see the fraud transaction is 0.172% for my data set. Now, I want to see a proper, the proper graph, right? So proper graph, how can you make that? So this is something, it's going to give you a dataset visualization. So I am going to use a bar plot over here using SNS, that is Seaborn. So Seaborn is also a same like Matplotlib. You can use Matplotlib as well for for the bar plot. So here I use Seaborn, right? Now what I say, now I already have X axis will be my fraud transaction and Y will be my genuine transaction, right? Now I am going to plot my data, and there I said the color of that palette, that is blue. If you want to use something else, you can go for doing that as well. Okay, now I am going to execute that. Okay, let me do that. It is going to take some time or few time. Okay, you can see. So you can see 0 and 1. Okay, so this is how I got my bar plot. Now what I need to check, I am going to check my amount. What is the relation between amount and time? Okay, so in that case I am going to plot that. You can see amount is this and time is in a milliseconds over here, right? This is the relation between time and amount. Now in this graph we are going to check the amount distribution, right? What's the amount is basically when a person is going to take a transaction. What's the normal amount? So in this distribution graph, you can see there's a very little, if you guys can see over here, right? So for the most of the cases, okay, so for the most of the cases, the amount is like very low amount, right? But here if you can see there is a, so here you can see there is a little graph changing, right? So this basically is saying when your amount is getting higher, there is a possibility that your transaction is a fraud transaction, right? So this is the way your graph is trying to communicate with you. So your graph is going to give you a intuitive that maybe when the amount is high, the transaction is becoming more, you can say that transaction is become more fraud. There is a chances of probability is high. Okay. Now we see some of the outliers or anomaly detection. So in my case, I want these outliers or the anomalies, right? So this is basically when I have a huge transaction, right? Maybe this is my outlier on the analysis on the or the anomaly in my data. But this is where I can find, okay, so when my transaction is very high and when these attributes are changing, that time maybe my transaction is a fraud transaction. So in this project, we are going to keep our outlier. You can see these are our outliers, right? You can see over here, the amount is high. The outlier, you can say, okay, they can be these three two are my for sure outliers. But you can see these can be like the normal genuine transaction as well, right? Okay, so here you can see this is how we actually find our outlier. Now we came to the what? We came to the correlation matrix. But why do we need correlation matrix? So basically we need correlation matrix to understand how our each and every attributes are connected to each other, right? To get that correlation matrix, we are going to use dot core function. Now, what I need to say, I am going to provide my data. So if you can see in the data, you can see over here, if I can write over here, be like this. Okay, no, anode will be there, I think. Yes, if you can look at this, you can see the class, okay? So you can see over here, class and V90 is quite correlated, right? And there are some time and maybe if you can see over here, time and amount, right? Time and amount is also very correlated. So this is how we can understand our correlation for the data. Now it comes the machine learning part. Now, as I said, I am going to give 80% of my data to train our model. But 20% of my data will be not seen for my model, right? This will be the new data for my model. How can I do that? In the X variable, I am going to take all the attributes except the class. And in the Y variable, I am going to take only the classes. So here you can see I have X train, X test, Y train and Y test. So I have two parts of the data. One is containing attributes, one is containing class. So I have divided them into two parts. So I will have 4 variables, right? So here I am going to use train, test, fleets function, and there I need to provide my data, that X and Y. Here I said my test size equals to 0.2. That is means that 20% of your data. And random state equals to 42. Why do we use random state? Is basically it will take randomly data for the making, testing and training part of your data set. There is no hard and fast rule when you say, okay, I want to have a random state. So basically there is no hard and fast rule that it will take the first 80% for your training and second 20% for your testing. So it can be any data. Right, now we are going to call our logistic regression. So you can see I already called my logistic regression function, that is logistic regression. And if I want to feed my model, to train my model I am going to use dot feed function, and I am going to provide X train the attributes and Y train the classes. Okay. Now I am going to predict my data. How can I do that? Using ypred equals to logistic. Okay. So here you can see I am going to write logistic.predict function. This will help you to give the prediction. But when we are going to give the prediction, we are not going to give the label. We are going to only give the attribute. You can see X test. Now I want to see my accuracy. So in accuracy check, we use confusion matrix. Is one of the concept that when you go for checking your accuracy, you can calculate your accuracy from the confusion matrix. But here we have a direct function called accuracy, where you will get the direct accuracy for your model. You can see my model is working with 99.85%. So we can say my model is working quite fine, right? So you can use this model. You can use some other testing data set as well, and then you can deploy your model. So your model is ready to deploy.
Now, as for the credit card industry, you become delinquent after missing a payment for 30 days, right? If I don't make a payment, then I become delinquent. Default usually happens after 6 months in a row of not making at least the minimum payment due. Okay. So the difference is I become delinquent if I have not made the payment in 30 days. But if I have not made even the minimum amount due in the 6 months in a row, then I have defaulted, right? However, whenever a bank is analyzing the data, they will consider you as a defaulter even if you have missed out one payment cycle. Okay, that's a very important difference which you have to keep in mind when you are analyzing a data. The data set which I have picked up also considers you as a defaulter even if you have missed out one payment. Why bank generally looks at data like this? Because they will keep an eye on you. If you have missed a payment or one cycle, or if you have missed a payment for 2 cycles, there is a heavy chance, or the probability of you getting into a defaulter is higher than somebody who has never ever missed the cycle. What is the case study which we have? Over the last 4 years, bank has observed an exponential increase in the credit card payment defaulters. Preliminary analysis was conducted by the bank to understand if any pattern could be observed based on demographic details, so that appropriate check rules could be imposed while issuing the credit card. However, this effort has really not benefited the bank. Hence, they have requested for your support. Okay? So bank has done some preliminary analysis, but they were not able to find out that if there are, what is the reason for somebody defaulting it. This time, bank has also collected some additional information related to their bill amount, payment amount, along with how much each customer really uses the bank option to carry forward the payment amount to a next month, or payment delay was observed for how many months, or are they using a revolving credit amount. So your task is twofold. One is identify if bank needs to impose some rules based on the insights generated from the historical data, so that they can keep an eye on the potential defaulters. Second is build a model so that bank can estimate the probability of a default. What are we expected to do in this episode? We will do an exploratory data analysis for each independent feature with all other independent features and a target feature. We will perform some statistical tests to understand the feature significance. This is what you are able to see the data set. What are the fields you have it? You have an ID, which is a running ID, balance limit, which is a limit available on your credit card, gender, education level, marital status, age. Then you see a set of flags, right? What these flags are, when I go on to the Python notebook, I'll explain it to you. These flags, the values which are available here, they carry some meaning. But these are flags which are available. You have a flag available for September, August, July, June, May, and April. So it's a 6 months data set which has been given it to you. Then related to these months, you have the bill amount. And for the same set of months, you have a pay amount, which means what was billed for each month and what you are expected to pay each month. Then you have a default column, which is a target column. And as I said it, even if you have made the payment later on, which means let's assume there was a bill which was generated in the month of June, I have paid in the month of August, which means I just missed out a July cycle. I am still being called as a defaulter, right? Because bank will keep an eye on me because I have defaulted once for a payment. So what you're looking at right now is my Python notebook. So the standard libraries, I don't think so I'll have to spend time on that. I'm sure all of you are completely aware about these libraries. Any specific function which I'm using from a library which you are not aware about is what I'll explain it to you. I have included this part of the code so that if there are some deprecated versions of the library available, I do not want to see that warning messages. So that's why I have said it. As I have promised in the beginning of the session, I will try to spend some time on the code, guys, but my interest, and I'm sure all of you will appreciate it, will be more on terms of what we are trying to do and why. I have loaded the file here. This is what the file looks like. Pay September FL is a flag. Pay August FL is a flag. Pay July is a flag. Now this flag has values as -2, -1, 0, 1, 2, 3, 4, 5, 6, 7, 8. What does it mean? If the value is -2, which means it is an inactive account. Okay. If it is -1, which means somebody has paid the due which was there duly, complete payment was made. 0 means the customer is using a revolving credit. 1 means there is a payment delay of 1 month. 2 means payment delay of 2 months. 3 means payment delay of 3 months, and that's how it goes on. Okay. So these are flags for each month. And this is what is the bill for the month of September, and this is what is the payment for the month of September. So what do we have? In addition to the demographic information, we have data available for 6 months payment, 6 months bill, and the flag which represents what has happened in that month. Fair enough? Now, what we will do is, as I've said, whenever we are doing an exploratory data analysis, our interest is to really generate insights from each variable. What I will do is I will show you how the EDA is done in a practical scenario, right? Normally, the entire modeling cycle, if it is a 4 months modeling cycle, which means from the day somebody gives you a business problem to the day you are expected to deliver the model, if it is 4 month cycle, then believe me, practically more than 2.5 months you generally spend on an exploratory data analysis. One of the important exercise for an exploratory data analysis is data cleansing. Today, I will not be stressing more on a data cleansing, but the second important part is looking at every variable along with all other variables, which means I will pick up a variable and I will study that variable with every other variable. So the first variable which I'm picking up is age. I will study age with every other independent variable, which means I will look at how age is with marital status, with education, with gender, with balance limit, with all the flags, with all the payments, with all the bills. And I will also study age with default. Okay. When I'm doing a study, I will perform this appropriate statistical test to ensure how significant the relationship is between the variable, which is age, and the second variable, which I'm looking at. Fair enough? So let's get started. First variable, as I said, I'm picking up age. So the first plot which I'm making is a distribution plot. Now, so the library, standard library, SNS is what I'm using it. I have made a box plot also along with it. Normal practice is to study the distribution in a box plot together, and that's why I've made this together. What is the first observation which I get to see from a age? When I'm looking at a distribution plot, and this is a KD curve which I have made it, there are certain peaks which I'm able to see in the age variable. What I can find out is that age is probably not normally distributed. From the box plot, I'm able to make out that I have lot of extreme values or outliers beyond 60 as an age. When I make a distribution plot, Python consider this as more as a bar rather than a complete histogram. And hence, to get a view on the complete distribution, I am looking at a percentile information as well, which means I am looking at how is the distribution at 10 percentile, 20, 25, 30 till 99. When you look at this, in the box plot, we saw that we have a lot of extreme values which are above 60. When I look at this, then the till 99 percentile, I have a value as 60. The maximum value is 79. So what am I able to see? That the data set which I have probably is little right skewed. I have a median value which is 34. I have a mean value which is 35.48. Then I check the skewness and kurtosis. Then what do I see here? That I have 0.73, which tells me this is right skewed data. And the data spread which you're able to see is from 21 to 79 years, right? So I have got the basic information available from these plots. If I have to summarize this, then this is what we already spoke about. There are 4 peaks in the histogram at the age of around 28 years, 35 years, slightly above 40, and at least at 50. Most of the customers are between age 25 and 35. How do I know that? When I look at the information from 10 percentile, and when I look at the information which is still 60, then I have the age available as 37, right? Now, when I describe this as there is a skewness available, then what do we try to do is, yes, Baba, we are looking at only the age variable right now. And we are just trying to find out that how is the age distributed? Why are we doing that? We are doing to find out how is the age distribution, if there is any kind of a skewness available, because from a modeling perspective, the variable is assumed to be normally distributed, and hence I'm analyzing the age variable to see if that it is not normally distributed. Then can I make this normally distributed by using what do we call it as transformation. So now, although there are certain standard rules which are available like a box-Cox transformation, I have tried doing a square root transformation to find out whether the square root transformation will reduce the skewness. I have got this as a skewness value. When I print the square root of the age variable, I have done a root of 10. This is the skewness value which I get it. I have done a log transformation. This is the skewness value which I get it. Now, if I have to compare, then starting from the skewness which I got it as 0.73, by doing a transformation, which is a log transformation, we have been able to achieve a result which is 0.24, which means when I get into a modeling, from a model performance improvement perspective, I can look at doing a transformation of an age variable to a log. Now, I'm looking at a age with a gender and default. This is what we call it as a bivariate analysis. So what we have done till now is just a univariate analysis for an age variable. Now, when I'm doing a bivariate analysis, I know that there are 2 levels available for a gender, which is female and male. So I am making a distribution plot for the group, which is a female, and for the group, which is a male. I'm trying to impose on each other so that I'm able to analyze that. Then I will look at how is the distribution of age with respect to a gender, which means I'm making a box plot with respect to age. Then I am putting a hue there as a default so that I'm able to analyze that separately. Then I will make a distribution plot for finding out the variation or a distribution for both the categories, which means when default is 1 and when default is 0. So the first was analyzing the age variable with respect to each gender. This one is analyzing the age variable with respect to people who have defaulted and who have not defaulted. Okay. Now, when you look at this chart, which is a distribution plot, wherein the red one is female and the green one is male, what are we able to see? What is the first input which you get to see from this plot? Only one peak available for a female, wherein I have multiple peaks available for a male. Now, if I relate this back to the univariate analysis which I did for age, wherein age was showing us multiple peaks, then probably I'm able to build a story saying probably the peaks which I saw in the univariate analysis was belonging to a male, because when I do an analysis separately for a female and male, the female has only one peak. When I look at the distribution or a box plot, then what does it tell me? The median age for a male is a little higher than a female, right? The 79, which was the age group which was available, it belongs to a male. When I look at a default, which means there is not much difference in the median age between a defaulter and a non-defaulter. When I am looking at the distribution of a default, which means is there a variation in the records which pertain to default and non-default, then also I don't see a varied distribution. When I am looking at a distribution plot, which is with respect to defaulters and non-defaulters, and I have the green color, which is representing a non-defaulter, then what do I see here? Then the chance of somebody defaulting is less, correct? Now, if I'm not very comfortable in reading the numbers like this, then I will do a further analysis by looking at a percentile value. Now, what do I see here? This is the percentile distribution for each category of defaulter with respect to a age. What is the first observation which you have by looking at this chart? What is the first observation? You were able to see the box plot for a default and a non-default. I have made a similar chart here in terms of a percentile value. This box plot was telling me that there is not too much of a difference available. But as far as the IQR range is concerned, probably for a male it is little higher. And that's what I'm able to see here as well. Which means probably till 70 percentile, I do not see a much variation between 0 and 1. Whereas beyond that, I do see a little variation in terms of the age group available. When I look at this analysis with a gender, which means I am trying to find out, is there a variation available with respect to a defaulter? And when I compare it with male and female, then the non-defaulters, female and male, it shows me that the age group is approximately on a similar value, still probably 60 or 70 percentile. And the same goes with the defaulter as 1, wherein till probably 70, I do not see a much difference. So from a combination of a univariate and a bivariate, which means I have looked at age with respect to a gender and default, what can I conclude? What can I conclude in 2 sentences? Age is definitely not coming out to be a significant differentiator between a defaulter and a non-defaulter, including the gender as male and female. Now, the test which we are performing here is a 2 sample t-test. Why we are doing a 2 sample t-test? Because you have 2 levels available as a default, right? What does a 2 sample t-test would do is, because I have 2 values, I am considering that as one sample which is for a defaulter, another sample which is for a non-defaulter. What will be the hypothesis? There is no effect of age on being a defaulter or a non-defaulter, right? Which means mean of age for a defaulter is equal to mean age of a non-defaulter. What is an alternate hypothesis? That yes, there is a difference. So what have I done? I've created two groups. One is for default as 1, second is for default as 0. When I do a hypothesis testing, it is a 2 sample which I have created. So I do a t-test for a 2 sample. What do I see here? I get a value at 0.01, right? Now the statistical test is telling me there is a difference between the age of a defaulter and a non-defaulter. Okay. So visually speaking, when we were looking at an age, we got to see that there is hardly any difference in terms of a median line, which we have it. But when I perform a statistical test, then what does the test tells me? No, there is a difference. So I cannot assume that the mean age for a defaulter is equal to a mean age of a non-defaulter. So what will happen is, the next exercise which I have to do is, I will have to find out, is there a specific age group which creates a difference? And that's where what comes into a play is WOE, weight on evidence, and what we will, and an information value, which means we will try to find out by converting this into a bin to see, is there a specific age group or a bin which creates a difference. Now, so we looked at age with gender, we looked at age with default, we performed a hypothesis test also. Now I'm doing a bivariate analysis of age with the balance limit along with the default. Now, because age and balance limit both are numeric variables, so I have used a scatter plot here using a hue as a default. This is the diagram which you get to see. What is your first observation with the diagram? If the balance limit is on the higher side and age is also on the higher side, the chances of somebody defaulting is less. So I'm just looking at these many dots. These dots are giving me some information. Other than that, I do not see any kind of a pattern available. Am I right? So what are we concluding? We are saying that probably if the balance limit is on the higher side and age is also on the higher than the median age, then the chance of somebody defaulting is less. But why did I use the word probably? Because I do not have lot many data points communicating that as a mean, right? So that's why I've used the word probably, correct? I'm able to see this kind of a relationship with the correlation also between age and balance limit. I see only a 0.144, right? So it's not that I have age and balance limit highly correlated. So from a credit card company perspective or from a business perspective, I am saying that it's not that age really defines a balance limit. It's not that somebody with a higher age will have a higher balance limit or vice versa. Okay. Now I'm looking at age and education along with the defaulter. First of all, I have 5 different levels of education which is available: university, graduate, high school, unknown, and others. Right? Now, what am I doing here? I am making a plot wherein I am studying each group. Okay, one important point which I just want to highlight here is, you would have realized whenever I get hold of a categorical variable and when I'm studying a numeric variable along with it, I always make a group and study that. Which means with the gender, I created a group of female and then I created a group of male and studied that. Similarly, within education, I've created 5 different groups along with an age, which I'm studying it. Then I'm studying the box plot of education and age, and I'm studying a box plot with a hue as a default. What is the impression which you get from the first chart, wherein you have multiple distribution plot available for each type of an education? What do you see? So you have a graduates which are below. Age for a graduates is on the lower side, right? When I'm looking at the unknowns and others, these 2 categories, I look at a box plot. What do I see? Median age for the high school is the highest, right? That's what you're able to see here. When you are looking at the other age groups, then probably university and graduate median age is approximately the same. The second highest which you're able to see is an unknown category. When you study them with the default, what is the difference which you are able to see here? The median age for the people with an education level as unknown is high if the individual has defaulted. What about other? So we are able to get hold of some information about the education, right? So when I look at the percentile distribution, then probably you're able to read this chart properly. So I will not spend much time on this. This is, if you are not able to get the information clearly from the chart, you can just look at the distribution and you get to see the similar value. Couple of things which I just want to show you here in terms of a skewness and a kurtosis is, so this we saw it spread for all categories is similar except for other category. People who are high school educates are mostly older. The average age is higher than the rest of the categories. It is not skewed, but a little platykurtic can be seen from the negative kurtosis. So if you look at the people with high school graduates, the kurtosis value which you have is negative. What does that indicate? What does a negative kurtosis mean? It's a flat peak which is available, right? Then most of the variables are right skewed because you have all the values. The graduate has a skewness which is greater than 1 and the kurtosis which is also greater than 1, right? What does a kurtosis value greater than 1 means? High peak, right? So you have a high peak available for individual who are a graduate. You have a negative or a flat peak available for people who are in high school. Now let's just go back and look at this. What did we concluded? We said the median age for a high school graduates are on the is high. You look at this value, right? What does it tell me? So high school graduates are probably the older ones. Now, are you able to relate it back? I have a peak which is showing me a kurtosis as 1 value, probably because of this which is available in the data set. Now, so we were able to conclude for others and a unknown category. Now, the test which I will perform for age and education is what? I will perform an ANOVA test for age and education to find out, is there a significant difference in the age with respect to a education category? Then what do I see? I reject the null hypothesis, which means there is no impact of an age. This is the hypothesis which I am rejecting. So what am I concluding? There is at least one category in education whose mean age is different from other categories, right? So what we try to find out is, we try to find out which group is different, right? So which combination is different? So graduate high school, graduate other, so graduate with all other, high school with the other categories. When we perform this test, it tells me which is the group which is different, right? So graduate and others and university. So leaving aside the other category, which does not show a significant difference between the with respect to university and graduate, all other categories have significant difference in their age. Now, I am looking at age with marriage and default. I'm still not done with the age variable, guys. So I'm sure you are able to see the intensity and the detail in which we really go in studying the variable. Marital status, you have 4 levels available: married, single, others, and unknown. Same logic, created 4 different groups. Now, when we make a distribution plot, so I will make a distribution plot, then I'll make a box plot, and then I'll make a box plot. When I'm looking at the distribution with respect to a age, then the one observation which we have is that probably I can make a statement that most of the records which are with the single have a age less than 50. Most of the records, because I'm not talking about the extreme values here. The median age for a single people are less. When I'm looking at a married, then it is approximately close to 40 or 38 is what I see. the highest median value which I have is for the others category, right? My interest is for the defaulters. What is two observation which I get to see, which I can tell to the business about the marital status and an age. Unknown category, I have a median which coinciding with Q3, right? Then for a others category, I do see a difference in the median age. Otherwise, when I'm looking at a married and a single, then I do not see a difference, right? Although I'm not doing a data cleansing exercise today, but these kind of observations also help you to do an imputation. If I have to decide on doing an imputation for others and unknown, these observations is what I'll keep in mind. So in a nutshell, if I have to conclude, then for the defaulters, business has to keep an eye on others and unknown categories. So what is the conclusion which we have? Married category had multiple peaks. Most of the singles are below 50 years. There have outliers beyond that average of single. Median age is highest for others category. Unknown marital status defaulter median is almost equal to 75 percentile. Single category is quite right skewed, which is understandable. When I do a hypothesis testing between age and marriage, one more time I'll use an ANOVA here because I have too many levels available. Then what do I see? When I use an ANOVA here, there is at least one category in marriage whose mean age is different from other categories. Similarly, I perform a Tucky HST to find out which is the combination which is different. Okay. So I have done age with gender. I have done age with balance limit. I have done age with marital status. I will go through age with the pay flags and then I will take a pause. I am looking at a bivariate of age with bay flags along with the default. I am doing, rather than doing it for all the flags, I'm just doing it for a September because September is the latest month which I have it. Now, when I look at this diagram, what can I conclude? Pay FL, pay September FL greater than 0, age scale less than 50, more defaulters. Absolutely. These are the two observations that you have it. Correct? So now I'm just looking at age and bill amount. I'm sure all of you have got the hang of it that whenever we need to do it. So I've just created a combined chart for age and bill amount. Now, one quick observation which I just want to show you here is, now this is the bill amount for April. This is the bill amount for May. And then you have the amount for June, July, August, and September, right? Now, when I'm just looking at this data, the first time when I made the chart, I thought that somebody who has a bill amount which is negative, right? Look at this orange. Somebody who had a bill amount as negative has defaulted. What does it mean? That probably this individual needs to be studied before that also, correct? Otherwise, somebody with the negative bill amount cannot default. Observations you need to keep in mind whenever you are looking at this data. Similar to the bill amount, I have made a data for a pay amount. Another observation on the similar kind, which I am able to share it with you is, bill amount, we were looking at for a September, right? For a pay amount, the first quick observation which we saw it earlier also was, if the pay amount is high, right? If the pay amount is high and age is of the median category, then the chance of somebody defaulting is less because I have a lot of blues here. Then the chance of somebody defaulting is less, right? That's one observation which we have it. The second one which I really want to show you here is, this is the data which I have for pay September. And what we are able to find out here is, the pattern which we were able to see in terms of a defaulter looks a little different, not too variant, but from, if I need to compare this with the month of June, and if I need to compare the pay of September, then for the month of June, even for people with less amount and less age had a lot of defaulters. That's what I'm not able to see there for a September. So I don't know what really happened in September, or maybe because this is the last month data which I have it, that's why I'm able to see this. Okay. So this is where I complete the analysis on just the age. What I will do is I'll start the session by talking about the weight of evidence and information value. Because yesterday, what we wanted to find out is, yes, we were able to identify that this is what age is telling us. From a statistical test perspective, also, we are able to identify that whether the variable is significant or not. Then the next step before we get into a modeling is to understand whether this variable is significant and how significant the variable is in terms of predicting it. What I plan to do today is I will help you out in understanding what is weight of evidence and information value. I will spend a good amount of time in talking about that. And then I will take you through the feature selection and a feature engineering as a process. Okay, so these two are a little different. And then we will see how these feature selection and feature engineering help us to do a model building. Before we end the session, we will try to find out if there are anomalies available in the data set. Okay. Just a quick recap. Maybe you would have, you are completely aware about what exactly is a feature engineering or what is a feature selection. I will just do a quick recap on these concepts which I'm talking about. Okay, we'll just spend 10 minutes on that before I move on to a Python notebook. So what we are talking about is what exactly is a feature engineering? It's a process of using the domain knowledge to extract features from raw data. It's an iterative process. What do I mean by that is, from the domain knowledge, we decide what features to be created. We create those features. Then we check how this feature has worked in the model. We try to find out if the feature which we have created, has it improved the performance of the on the test data set or not. If it has not, then we discard the feature. Okay. What exactly is the difference between feature engineering and feature selection? Feature engineering is which enables you to build more complex model than in comparison to what you could make with the raw data. It makes you easy to interpret the data which is available. That means, again, it goes back to the fact that we're using a domain knowledge. What is a feature selection? From the given set of features, we try to find out what are the features which are significant. It will reduce the risk of overwhelming the algorithms, which means we are just, let's assume if I have a data set which has many features available, we try to reduce the number of features so that we do not end up in the risk of many features available in the from the modeling perspective. Time, it trims down the computation time because I have reduced the number of features. Yesterday we saw it that we need to do a transformation if the variable is not normally distributed. We also understand that we do a scaling of the variables. Can this be categorized as feature engineering? To an extent, yes, but not really going with the definition which we said as feature engineering. The word feature engineering is commonly used when I have engineered the available features. When I use the word engineer means I've tried to create some new features out of it. Some common methods which are used for creating the features. If I have a continuous variable, then we try to convert that into a categorical variable by doing a binning. Generally, it is seen that in the model, if I have a categorical variable and if the variable is significant, then the model performance really improves. So we try to convert a continuous variable into a categorical variable by binning it. Sometimes we do some mathematical operations by just defining the ratios or performing mathematical operations onto one or two continuous features. This kind of a work is normally done for banking and financial services data. Today also, when I am creating the features, I'll probably use one of these methods. How do you do a feature engineering for an object variable? We try to combine two or more categorical type of an object. Yesterday, somebody had a query of saying that if I have many categorical variables, should I be looking at a data with respect to that? Then I did mention that we look at combining the categorical variables by either using a domain knowledge or by just looking at the percentage distribution we have it. we use an encoding, we use grouping of one or more multiple category variables, we perform some mathematical operations like count, max, and min, and we try to use those values which we get it. Date variable, it's a very unique kind of a variable which we have it. We try to extract year, quarter, month, day of the week, weekend, seasons. So a lot of options which we have it for a date variable, we try to do it. For a text variable, we try to convert the text, which is an unstructured data, into a structured data. And we try to see that if there are some kind of a numbers which are there, or if there are two strings which are together, can I just separate it? So those are the kind of options which we use it. Or we use any combination of the above mentioned suggestions, but the story does not end here, because feature engineering requires a domain knowledge, right? What I just shared with you were the some standard suggestions and the techniques which we use it for doing a feature engineering. One caution you have to use, it's not necessary more is always a merrier in case of a feature engineering. Okay, be cautious about the curse of dimensionality, which means if I have number of rows, the number of rows available in the data sets are not too many, I should not be creating a lot of columns, otherwise I'll fall into a curse of dimensionality. Fair enough? So let's get started. I've loaded the data set. I've just loaded the data set and done nothing, right? Age was one of the variable which we have it. Now what I'm trying to do is I'm trying to convert this age into a categorical variable by binning it using the values 0, 25, 34, 44, 100. How have I arrived at this value? Learners who have attended the session yesterday, they would be able to relate it. I have looked at the percentile distribution, and based on the percentile distribution, these bin categories have been defined. Now, once I do a cut, this is the value which I get it, right? This is how the table look like. So between 0 to 25, I have these many people who have not defaulted. I have this number which has defaulted. Now I'm just moving on to a simple Excel sheet just to tell you how do you calculate a weight of evidence. Now, the people who have defaulted, we call them as events. People who have not defaulted, we call them as non-event. Because for us, in this data set, event is the time when somebody has defaulted, which means I have a value as 1. Then what we do is we calculate percent of event, which means I look at the summation values and then I calculate a percentage. Very simple formula, 1032 divided by 6636. Similarly, percentage of non-event is 2839 divided by 23364. Okay, this is how these values have been calculated. What is weight of evidence? Weight of evidence is the natural log of division of non-event percentage divided by event, which means good divided by bad. Okay, what is a bad? Somebody is defaulted. So good divided by bad, natural log of that gives me a weight of evidence. Then I have an information value, which is nothing but the non-event minus an event multiplied by weight of evidence. If I take a summation of this, I get an information value. Now, this is what an algorithm does it automatically. I'm really not sure if somebody has tried out decision tree, wherein we just try to create 10 deciles, and then we try to find out how many records I have in the first decile, second decile, third decile, and then we find out something which we call it as a KS value. This is nothing but an information gain. So what I have tried finding out is a summation of an information value. Just logically look at it. What am I trying to find out is I have done a division by a bad event, right? So when I do a division by a bad event, I'm trying to find out how much weight in the given data set is given for a bad event, right? Whenever I'm trying to find out a ratio, like let's assume this case, when I've tried to find out a ratio for an event, I have divided by the total value, right? So it gives me the contribution for 0 to 25. Similarly, herein I have tried to find out the contribution of a bad event over the non-event or a good event. So that's why I do a division here, right? Just to give you an idea why do we a natural log is because whenever I am doing this kind of a division, I try to find out the number which is not a big number, right? So that's why I take a log of it. The second reason for taking a log of it is because I'm just trying to see something which is normally distributed or not. Because this weight of evidence, I try to make a curve out of it. Why a natural log is something which is related to a mathematical formula. Now, if I look at this weight, right? Now, again, logically, let's understand this formula without mugging it up. What we are trying to find out, the information value. IV stands for an information value. Yeah, thanks, Nikita, for answering that. Now, what are we trying to find out is the how much is the value contained in this bin, right? So the weight which I got it, subtracting the non-event from an event gives me a something. I'm just using a word residual, but something which is relevant for me, right? So non-event minus an event, I subtract it out, right? So I just get the value. It is like saying I'm finding out the weight. Something is 34 and something is 15. When I just subtract out 15, then both are at the equal number. The rest is the weight, which means 34 is this many values or this much number is higher than 15. That's what I get a weight out of it. So that's why I subtract it with the percentage value and I get an information value, right? So that's a logical way of understanding it. Then I do a summation of this because I'm looking at age as the complete variable, not just a specific thing. I'm moving ahead with an assumption that I was able to do a WOE and IV for all the variables. I have done a complete ED analysis. There was anything which was related to doing a cleaning of the data set has been done. Now, in the model building, what I will try to show you is what are the steps which we follow and how do we actually develop a model. I will not be showing you multiple algorithms. Like I will make a logistic and then decision tree, then random forest, then KNN, then naive Bayes, bagging, boosting. No, I will not do that. The way I plan to help you out in terms of a model building is I will show you how it is practically being done. So let's assume logistic is the algorithm which I have decided as a base model, right? Whenever we start building a model, we decide on one of the algorithms as which is the base model. So what I will do is I will look at the logistic model in the original data set. Then I will do a transformation, which means I'll scale it. Yesterday, I promised you that the age variable when we were looking at a log and all. So today, what I've included in the code book is I will do a scaling, show you what is an impact scaling makes on the logistic itself. Then I will rerun the logistic and identify the significant features. I will see what effect it has on the performance. Then I will do a grid search to see whether the grid search is improving the performance or not. Then whatever comes out to be the best model, I will use that as a base and then get into a feature engineering. Fair enough? So that's how the flow would be. Standard thing which I'm doing here, I'm just dropping in ID variable, converting this into a categorical. So I'm using a pd.categorical, getting the codes out of it, which is gender, marital status, and education. Original data set which I had, I've created an X and Y, which is the labels. X is the features, then it is a label which I have it. Then these are the features which I get it. I have standardized the features by using an STX, right? I can use the standard scaling way also. I just thought I'll let you know that this is the internal formula which is being used. I'm sure you would have seen this formula whenever we are doing a Z transformation. So the features which I got it, I have set features minus the mean value, the standard deviation. So this is how the features look like. Now what I'm doing is I have created one data set which is X train, X test, Y train, Y test, which is with the original one. I am creating another data set with the standardized feature, which I'm just calling it as XSTD. train XSTD test, YSTD train and YSTD test. Okay. Now, what am I doing here? I am trying to find out a feature selection, which means I am asking model to select the top 3 features, right? So I have said number of features as 3. Devesh, this is for you. RFE is the mechanism wherein I try to find out the best features, right? So what we try to find out is the algorithm in turn will run multiple times and tell me which are the best 3 features which are available. So I am running a logistic regression model, asking it to let me know what are the 3 best features. What do I get it? I get the 3 best features as pay September FL, bill September and pay August. Okay. Now, these are the 3 features which I got it. Now, what am I doing here? The standardized metric which I had, I have only taken out these 3 variables which were important. So I have got 3 sets. I have got one set which is with the original variables. I have got another set which is with the standardized variables. I have got third set which is with the important standardized variables. 3 important, right? Now, what am I doing here? I'm using a hyperparameter tuning, identifying the best C value from a regularization perspective. Using that, creating 3 models. First model which I have created it with the original data set. This is the confusion matrix which I'm able to see. What is your observation? So this is the confusion matrix using hyperparameter tuning, grid search, identifying the best C value, which is a regularized parameter. And this is what I get it, which means the original data set has shown me a precision and recall for a class of my interest, which is 1 as 0. I'm assuming all of you are completely aware that we do not use accuracy as a metrics to evaluate a model, because accuracy gets influenced by a majority class, right? So don't use accuracy ever for evaluating a model. My class of interest is 1, precision and recall is 0. This is a pathetic model. Now, my interest, okay, before I go ahead, my interest from a business perspective is I am looking at a recall. Whenever I am interested in less false negative, I look at a recall value. Less false negative, which means what? Bank does not lose the money. Whenever I'm interested in less false negative, which means somebody has been quantified or qualified as a negative and the guy is not really a negative. It means falsely it has been classified as negative. Whenever I want to minimize that number, I look for a recall. So from a business perspective, my interest today is on a recall value. Okay. Now, when I have created a same set of same set of commands, and I am using, what am I using here? I'm using a standardized version. What do I see as a confusion matrix? Now, when I use a third data set which I created, wherein I have only 3 significant variables, or the most significant variables would be a more appropriate word to use it. When I use that data set, I have a recall value as 0.27. Right? Same set of steps I've executed. So what am I trying to say? Whenever you are building a model, when you decide on one algorithm, you try to find out what is the best that algo can give you. Now, from here on, when I move on to, before I move on to a feature engineering, I will use another algorithm, find out what are the best value which I can get it, which means, let's assume if I'm using a decision tree, I try to find out the important features. Or if I'm using a random forest will tell me based on the feature importance, which are the best features. I will make a model and see, right? At the end, when I finalize a model, before I use the feature engineering to further improve the performance, I will try to find out through the voting effect which are the variables which are the most significant variables, and then finally create that model which have been identified as the most significant variable. That is the model which I'll give it to a feature engineering. Okay. So I logically follow a process, not a haphazard way wherein I try out all possible algorithms and see what does a confusion metric look like. This next step, which I plan to show you now, is how do I improve from 0.24 now? That's where feature engineering comes into play. So your life as a data scientist will not just stop with identifying the significant features and improving the model. No, you have to get into a feature engineering. Feature engineering is an iterative process. This requires your domain understanding. Okay, so I am getting into a feature engineering now. The first feature which I am creating, I am assuming for this discussion, I am assuming that the model which I created as a logistic, I have tried all multiple algorithms, and logistic through the significant features has come out to be the best model which I can create. Okay, so I have assumed this is a best model. Now I'm going ahead with the process of improving the performance. The first feature which I'm creating is, I just thought that I will add all the flags which I have it and create another feature which I call it as a risk value. Right? Simple arithmetic which I've used, just added the values which are available in all the flags, created a variable which I'm calling it as a risk value. Ideally speaking, what is done is you create a feature, you add that feature into the final model and see if the performance is improved or not. However, for this session, I will create 3-4 features and then show you how it has worked on a model, right? Only for this session, so that I do not leave the flow of creating the features. Practically, I'm just repeating again, practically you create a feature, add to the model, see if the performance is improved or not. If not, then go ahead and create another feature. Okay. So this is the first feature which I've created, risk value. I am just trying to see how does the risk value look for a defaulter and a non-defaulter. So I have these blue bars as, so I'm creating a distribution plot again. Any new feature which you do it, you are expected to do an exploratory data analysis of that feature also. So that's what I'm doing it here. So from the diagram on a distribution plot and a box plot, it looks like that probably this will create a differentiator, right? I'm able to see a lot of difference between a defaulter and a non-defaulter. So maybe this might just create a good value. Just to find out whether risk value has captured the required variance or not, I've just created an OLS. Logically speaking, because it is a summation of all the flags, it should have captured it. I'm just giving you an idea that how do you check it also. I've just created a regression model. It gives me a R-square value as 1, which confirms that risk value has captured all the flag information which is required. So now what am I doing here is, I will use this risk value as I go ahead. So this is the first feature which I created. Second feature which I have created is, it's a sum of average bill amount for all the months divided by 6. So bill amount for April, May, June, July, August, September, all the bill amounts, I've just created an average divided by 6, right? And I'm calling this as a bill value. Then I'm just trying to see how is this in variable distributed. Now, when I look at a bill value in terms of a defaulter and a non-defaulter, and even on the distribution plot, it does not show me a very great result. However, if I just try to find out if a bill value is less than 0, what is the probability of a default? Then it's just 51, right? So it means people who have a negative bill value are definitely defaulters. Correct? Third feature which I'm creating, again from a domain perspective, is by subtracting the payment of this month to the previous month's bill. So I am creating pay September minus bill August, pay August, bill July. So this is how I have created a variable divided by 5, because I do not have a pay October, right? So bill September, I cannot use it. So I have divided this by 5, created a bill pay value. This is how bill pay value looks like. Okay. What do I conclude? People with positive pay value are more likely to default, which makes sense also. This is one important feature, as this has almost no defaulters on the negative side. The people who pay more, their bill are more likely to not to default, right? So that's very obvious. Feature number 4, which I am creating, what am I doing here is sum of pay amounts for all the months divided by the limit balance. So I am just created, first of all, the first variable, which is just an average, right? This is to tell you that I could create another feature by dividing this pay amount with the limit value also, which I am not showing you here, but I have left that as a comment. So this is what it shows me. Okay. Now, 4 features which I created, right? There are n number of features which you created. 4 simple features I created. And just to tell you what was there in my mind when I did that. I thought, let me just take an average of the bill amount. Let me just take an average of the pay amount. Let me just add all the flags which are available and logically create a bill value by just subtracting from the previous month amount. Okay. The first feature which I created, I have just tried to make a model by including this feature 1, which is a risk value. Okay. When I create a model by including a risk value, my recall has gone down to 0.24. So the best model which I got it, I have added risk value as a feature and my model performance has gone down, which means risk value is definitely not adding any value to the model. Okay. Then what I did was I added a third feature. Logically, you should add the second feature, then the third and the fourth. From the session perspective, I directly added the third feature. What was the third feature? Which was created by subtracting the previous month bill, right? This was the third feature which I created. When I added the third feature in the model and when I created the model, what do I see? I have a recall which is now 0.28. Okay. Which means that I should have this feature included in the final model because it has improved my recall by 0.01. Believe me, once you have tried out all possible options, the increment which a feature engineering would do it will be only in points. 3 points which I just want to highlight here before I open the floor for queries. First is, it's not that and every time feature engineering will add to the performance. Number 2, it is not mandatory that whenever you create a new feature or you need to create many features. It's not that I should just keep thinking I should create some 100 features. No. Third, whenever I'm doing a feature engineering, the addition which I get in the performance or the increment which I get in performance would be very little. So you should not expect that your model was something giving you a performance or a recall value as 0.22 and suddenly you created a feature engineering which gives you a value as 0.77. If you have such a great jump, and these are hypothetical numbers, guys, practically, as I said, you will only get a jump as 0.01, 0.02. If you get such a jump, which is a clear indication that the original model which I have created have not utilized the variance available in the given features. What is the variance? Okay. So when I am looking at this row, when I'm looking at every row in a data set, the value of 1, which is indicated here, is based on what are the values which you have it, right? Which means the variability available in a feature is being used to give you a value as 1, right? That's how model learns it also. So how the model learns it is, or how the algo learns is, looks at all the 1, look at what is the values which are available in each feature, looks at the variance which is available in that feature and keeps in mind saying if this is what the variance is, the chance of 1 is high, right? So if you are not able to get a recall of 0.77 earlier, which means I have not utilized the feature properly in the initial model. Imagine a model, right? I think all of you are at the juncture wherein you know the algorithms, right? So you have seen the data set wherein you get very happy about 0.80, 0.90. Practically speaking, when I know the recall is 0.55, right, I have put in all the efforts possible. The original data set, randomly, if I pick up a record with the default as 1, was telling me 40%. There is a 40% chance that randomly, if I pick up a record, is a defaulter. From 40%, I have raised it to 55%. Even that 1% increase will give me a thrill, right? Because I'm still fighting with that. So yes, for that 1%, I will create it. The another thing what we do is, whenever we have created the models, what we also try to do is, we also try to see, does the population which I'm looking at, or does the sample which I'm looking at comes from multiple population. That's where we use an unsupervised learning. Okay. Before I land on to that unsupervised learning, to understand that the population, the sample which I'm looking at, does that sample come from a multiple population? What is an implication of that? I just want to show you something which is very interesting. Whenever we get hold of a data set, we look for anomalies in the data set. Okay. And these anomalies could be based on our limited domain understanding, or it could be real errors in the data set. Couple of anomalies which I've just tried to find it out, and I'll just share that with you. And you will realize as we move ahead that are these real anomalies, or are there's something which is little lacking in terms of our domain understanding. The first anomaly which I've tried finding it out is billed amount is greater than the balance amount. Need to check if these customers are using the over limit facility. Billed amount is greater than the balanced amount, which means I am allowed to shop for 1 lakh rupees on my credit card, but the bill which the credit card company has produced is for 1,50,000 rupees. How, in which scenario this will be allowed? If I as a customer is given an overdraft facility. Am I right on that? Is that making sense, guys? I have a limit which is 1 lakh rupees, and I am given a bill amount which is 1,50,000 rupees, which means I was allowed to use a credit card over the limit which is allowed, which means I have the overdraft facility. Am I right? So what I'm trying to find out is, I'm just trying to find out the records wherein the bill for a September. Why am I saying that is? Bill for a September would have taken into account all that which has happened in the previous months. So I have 2115 records wherein the bill September, which also takes into account whatever that has happened in the previous months, is greater than the balance limit which is allowed. So we need to go back and check with the business that are these customers with an overdraft facility, or is there an error? Second, billed amount is less than the pay amount and still defaulted. Bill amount is less than the pay amount and still defaulted. Was any payment made for the previous month which is pending? If yes, why the same was not reflected in the billed amount? Are you getting it? I have a billed amount which is less than the paid amount, which means I got a bill which was for $100. I made a payment for $150. Correct? Now, what could have happened is that the previous month's pending amount, if it was any, why it was not reflected in the bill? Because the bill credit card statement should include that. I have 651 records in the data set wherein the bill for a September is less than pay for a September, and I have still defaulted. The one of the reason could be the bill September should be related to pay October, right? But my assumption is bill September has accumulated everything which has happened in the past. Third anomaly which I was able to discover is total pay amount is greater than the bill amount, still defaulted. Right? Just to get a confirmation on this, wherein I do not have an October month payment, I just included all the bill amount and I just totaled all the paid amount. And I have 495 records which are classified as defaulter, but they have made an excess payment. What is the reason why they are classified as defaulters? Okay. What am I trying to communicate through these anomalies is, you should always look at the data set, try to find out something which does not go well, which is which does not go well with your understanding of a domain. It could be that there is some gap in your understanding of the data. It could be the business has the different logic of capturing it, or these could be some anomalies, right? These anomalies are the ones which we call it as a real outliers, and we try to treat that. Now, what we also try to do, as I said, is we try to create a cluster. We try to do an unsupervised learning on the data set. What is the objective? Normally, what I've seen is when I'm doing a capstone mentoring, people, they create a cluster. They then one of the objective is we get the classes. We try to find out if this is a binary class or a multi-class problem. We use those cluster labels, create a multi-class problem, and work on it. Okay, that is really not the objective of a supervised learning. Unsupervised learning. Unsupervised learning is to ask if the data set or the sample which I have it, does it come from multiple population or not? So what I have tried doing it is I have tried using a k-means clustering. I'm sure all of you know it, that you have to normalize the data for a k-means. I will have to drop the categorical variables which are available. Okay, and I have created two components, which is PCA components I have created because I just want to visualize these two components. Understanding that an assumption is that these two components, they capture the maximum variance which is available in the data set. When I create a number, when I create a elbow curve, I get a elbow at 3, which means looks like 3 probably would be the best curve. When I create a Silote score, this also tells me this is the highest value I have it. When I make a plot, then I do get a clear segregation with the 3. What does it say? What does this mean? When I create a cluster, when I create 3 clusters from the given data set, I get a clear segregation. What does this indicate? These are 3 different population set probably. So ideally speaking, what I will try to do is I've just tried to find out the centroid also, just to see. So I've just tried creating a centroid as well, just to see is this overlap visually clear, or from mathematical perspective also, these are 3 separate populations. So what we normally try to do is, normally whenever we get hold of a data set, we have load of data set which we get it from a business. We look at is the data set comes from different population, and we may probably analyze these 3 different subsets and do an EDA, find out that is the observation right, it comes from 3 different populations, and then maybe based on that we decide which all population should be included from a merge perspective in creating a model. That's how the unsupervised learning is used for a practical data set, right? It's not just by looking at the data set and finding out, do I have multiple classes? Let's assume through the analysis, I'm able to find out, no, the sample does not come from multiple population. Then probably the data set which I have is not just a binary class. It's not defaulter and non-defaulter. There's something in between which is also available. And that's where we need to discuss with the business and understand that what this population is all about. Okay. So that's how it takes 6 months. If somebody got a shock of their life, that why it takes 6 months. So what have we covered? We looked at how do we find out the information value. We looked at how do we find out another way of significant features. What is the process which goes in making a model? How do we look at doing a feature engineering? How do we include the engineered features? We looked at anomalies and an unsupervised learning.
Now let us very quickly summarize today's video. In today's video, we discussed credit card fraud detection refers to the detecting of fraudulent activities related to credit card. Some of the important projects that we discussed in this tutorial were credit card fraud detection, COVID-19 outbreak prediction, and Pokemon trading using R. If you haven't subscribed to our channel yet, I want to request you to hit the subscribe button and turn on the notification bell so that you don't miss out on any new update or video releases from Great Learning. If you enjoyed this video, show us some love and like this video. Knowledge increases by sharing, so make sure you share this video with your friends and colleagues. Make sure to comment on the video for any query or suggestions, and I will respond to your comments.